Good afternoon, everyone. Welcome to the day six, concluding day of our FTP. Today, we have three sessions on different topics. Before starting with the session, I would like to inform you today's schedule. We have three expert sessions starting from 2 p.m. to 6:30 p.m. After that, the window of assessment will get open on AICTE portal for those whose attendance is more than 80%. The assessment window will remain open from 6:30 p.m. to 7:30 p.m. Make sure that you attempt the test in the given time frame. And in the last, we have our validatory session. Now, session one of day six. The topic of session one of day six is supply chain optimization. And we have with us Professor Chandra Jaggi, sir. Sir is a senior professor and former head, Department of Operation Research, University of Delhi. He is the national president of the Operational Research Society of India. He is a fellow member of the Operational Research Society of India and the International Science Community Association. He is associated with various reputed international journals, to name a few. He is a senior associate editor of OpSearch and associate editor of International Journal of System Assurance Engineering and Management, Springer. He has supervised 25 PhDs and 26 MPhil. His papers have Google Scholar citations as of 6,830 with H index of 39 and ITAN index of 101. He was awarded the Distinguished Educator Award by the Operational Research Society of India in 2023 and the Distinguished Professor status by the International Council of Social Reforms and Research on 14th April 2022. He is also the recipient of Shiksha Ratna Samman by Rotary Club of Delhi Uptown in September 2021. Amity Academic Excellence Award in February 2019 by Amity University Noida, and Lifetime Achievement Award by International Organization of Scientific Research and Development, Vishakhapatnam, July 2018. He was honored with the International Best Researcher Award 2017 by the International Science Community Association at the 7th International Science Congress in Bhutan. He has received the Best Teacher Award from the Grace India Educational Charitable Trust, New Delhi, for his outstanding academic contribution in 2017. He was awarded the IEOM Outstanding Service Award by IEOM Society USA in 2016 in recognition and appreciation of outstanding support, service contribution, and global community engagement in industrial engineering and operation management profession. He is a lifetime member of learned societies like Operation Research Society of India, Indian Science Congress Association, Industrial Engineering and Operation Management USA, Computer Society of India, International Science Community Association India, Society for Reliability Engineering, Quality and Operations Management India, Indian Society for Probability and Statistics India, Association of Inventory Academicians and Practitioners in India. He has been a member of various committees of UGC, CSIR, the University of Delhi, the governing bodies of the University of Delhi colleges, the Central University of Haryana, MDU Rohtak, Kurukshetra University, Banasthali Vidyapeeth, etc. Now I would like to invite Sir to start with session one of day six. Over to you, sir.
Thank you, Media, for the kind words. Thank you. I thank the Maharaja Surajmal, and especially I should thank Mamta, Dr. Mamta Gupta, who contacted me for this lecture. So I hope uh, people will like it, what I'm going to present. So I'm just going to share my screen to you all. Is it visible?
Yes, sir.
Thank you. Yes,
Yes, yes, sir. It is visible. The screen is visible.
thank you. Now it's okay. I'm audible also.
Yes, sir, you're audible.
Thank you so much. I'm going to speak on your optimization approaches for humanitarian and relief and retail supply chain to advance sustainable models, basically. I just will have some glimpses of the supply chain, and then subsequently I'll go into the humanitarian, or we say relief supply chain, and then we'll talk about closed loop supply chain, about how that works in our day-to-day life. Basically, supply chain management is nothing but it consists of a series of activities involving many optimizations through which the material moves from initial supplier to the final customer, and that is depicted in the picture, basically, that how the product moves from one place to another. Basically, there are certain components of any supply chain, that is a supply, then your manufacturing, then your logistics, and there is a demand. And Handfield and Nicholas defined this SCM is an integration of all the activities associated with the flow of transformation of goods from the raw material to the end user, as well as the information flow to improve supply chain relationship to achieve the sustainable competitive advantage, basically. Now, that is basically the picture we feel material flows from supplier through different channels to the ultimate consumer. However, the information flows both ways, from supplier to the customer as well as from customer to the supplier, and the financial flow comes from the customer to the ultimately supplier. Now, in supply chain, we have got different strategies. One is your push strategy, one is a pull strategy, and then we also talk about push-pull system, basically. What is a push? Push is basically consumer is not requested for that product to be developed, but it is pushed through the channels. Long-term forecasts are the backbone of this push system. Basically, what we experience for the push system is when we go to the market, maybe a chemist or maybe a multi-item display, the number of items are displayed, and even the shopkeeper, they have not asked for it, but the product which company has produced, for the awareness of the customer, they push it to the same channel. That is basically the push system to make customer aware of what is the new product coming into the market. Pull strategy is basically in a different way. Here the consumer requests for the product and pulls it through the delivery channel. Production and distribution are based basically on demand so that they can be effectively coordinated with the true customer requirement rather than the forecast. Now we talk about the push and pull system. Now this is basically the combination of the two strategy, planning and timings of your pull initiative with the push initiatives. You are perceived method directly with your primary audience, while this at the same time you utilize the existing or new targeted communication tools, that is from the push system, basically. That is where we try to look for this supply chain. Now this is basically broader picture of giving that what is the physical supply, material, and physical distribution, and there are different things, parameters comes into the all this, and that is what we, the lower one, we call it as an internal firm's internal supply chain, basically. Now here what we see, this is the scale, and we see two sides. One is a supply side, another is a demand side. Now, supply chain objectives may differ from situation to situation. Now, for the functional products, the cost efficiency is a critical factor. On the other side, when we are saying the push system, that is what comes here. The innovative products, then the responsiveness becomes a very important factor. And that is why the scale, it's difficult to make it balanced, basically. Now, efficient supply chain management must result in tangible business improvement. It is characterized by a sharp focus on your revenue growth, better asset utilization, and your cost reduction. What are the benefits? Now, in the benefits of supply chain is it provides efficient manufacturing strategies, reduces your inventory costs, provides better medium of information sharing between the partners, improves customer satisfaction as well as the service. Nowadays, whenever we are buying any big product or like a washing machine or dishwasher or refrigerator or anything, we do look for and ask for what is the after sales service. That is basically we talk about the service. Maintains a better trust between the partners, increases your cash flows, and improves quality and gives higher profit margins. We just define that what is inventory management. Inventory basically defined by Fred Huntsman as an ideal resource of any kind provided that such a resource has economic value. Absolutely true. That is what we day-to-day life, we come across all these things, but we never realize that we are holding some sort of inventory. And there is a saying that if money makes the world go round, inventory makes logistic go round. In any controlling any inventory system, the fundamental question which must be answered by what to order, when to order, and how much to order. These are the three basic things. And nowadays, we also come across to whom to order. That means we also try to look into which is a good vendor who supplies goods on time, on the right quality, and as well as in the right quantity. Excuse me. Now we talk about the relief supply chain management. See, whenever any tragedy happens, maybe earthquake, maybe flood, maybe tornado, anything happens. So there's a lot of problems we face in our day-to-day life. Here, what we thought of just trying to make it a mathematical model to look into that how this problem can be addressed. That is why we call it as a relief supply chain management. Relief supply chain management is nothing but it is a specialized field within the supply chain management that focuses on effective and efficient distribution of relief goods and services during the emergency, disaster, or any kind of a humanitarian crisis. The primary goal of relief supply chain is to ensure timely and targeted delivery of essential supplies to the affected population, aiding and supporting the aftermath of the crisis. That is important because we all see in such situation there's a lot of hue and cry, and we have just seen the Ukraine war, then Israel war, they're all going on. But that is also something which we need to look at and we try to understand what is happening. Here we just trying to just show that what is supply chain and how the relief chain works, basically. In relief chain, we are getting supply, whereas in supply chain, we had a supply, we are on the basis of demand, we are sending. That goes into the other way around, basically. Totally opposite, but that comes under your supply chain. Now here, the inventory relief chain framework represents an innovative and comprehensive framework within the humanitarian logistics. This is designed to address the challenges of relief supply chain. That is why we call it as a IRC, Inventory Relief Chain Model. Here we introduce the strategic and integrated approach to optimize the flow of essential goods and the services during the time of crisis. It considers the dynamic nature of the disaster response scenarios, acknowledging the inescapable role of each center in ensuring timely and targeted delivery to the affected population. Now, the proposed problem is basically what we are trying to do here is we consider problem is linked to a relief chain for distributing relief products, maybe your medicine, maybe food, maybe water, maybe daily essential, all things they come are essential in that scenario. And what we are trying to look into, we have divided into three components basically. One, we say it is a collection center, that is from where we are collecting the material. And then we say in a distribution center. Basically, collection center, then it comes to distribution center, then eventually it comes to the relief center. And this model incorporates the inventory management with the cost and other costs, assuming the disposable cost of damaged product for the considered relief supply chain. Because the demand of relief camp is considered assuming that all the affected people are not available at a single time. However, the new affected person keep adding that some left and relief camp during the relief distribution process. That naturally that happens because immediately you go to the relief camp and subsequently you move to a different places. Maybe some more people are coming and joining the relief camps. That is why we call it as a dynamic nature of this model basically. So that is a pictorially we define it like this. These are the collection centers which we have. Then we have a distribution center, and then we have a relief center. That is a pictorially representation of our proposed problem. Now, our objective is to optimize the cost of the whole operation, that is managing inventory and distributing relief commodities from the center distribution center to the relief center. Now, in order to determine the number of intermediate distribution center and the relief center, that is another objective we have. However, in the study, every relief center is considered to distribute the relief commodities because in a disaster condition, every relief center is inacceptable because you cannot escape from this. Now, these are certain assumptions which we have assumed for making it a mathematical model. Here we are considering the multiple products to be distributed to the respective relief centers according to the requirement of the center, the maximum probable locations of the collection centers and the distribution center along with the maximum capacity are known that we assume here. And then collection center is assumed to be an initial facility to distribute the relief product. The shipment of product is considered from CC, that is collection center, to DC, that is distribution center, and then from distribution center to the relief center. And we have assumed there is no direct shipment possible from collection center to the relief center directly. All our relief centers are connected with the distribution center rather than with the collection center. Each distribution center has enough storage capacity to fulfill the demand from the connected facility centers. For the distribution process of the relief products, we have considered that collection, distribution, relief centers, these facilities have operational cost because nobody had in mind that this is going to happen. So suddenly we have to open the collection center, then distribution center, and the relief center. Therefore, there is a fixed budget for operational cost for all the facilities. Now, for distributing a relief product, every product has its weight and shape. That means the model is formulated considering different shipping charges for every individual product. We have also considered some products damaged or deteriorated at collection center as well as at a distribution center. But the damage rate assumed at relief center is negligible. Why? Because we are doing the inspection at the collection center as well as at the distribution center, because during the passage, the travel time, some goods might get deteriorated or damaged, so that should not reach to the relief center. That we have, and accordingly we have put into a disposable cost also. Now, the model formulates assume that road, bridges, and other transportation ways are damaged at certain level. Thus, they result in more efforts in distribution process. Therefore, there is an increased shipping cost for the relief product from one center to another center. The increased shipping charges are assumed as a function of a risk factor associated with the centers. The risk factor is nothing but is a probability of level of to which the transportation method get damaged. The impact of the disaster on the region, here the risk factor is only associated with the distribution of the relief center. And there is no bound on the vehicle fleet size because the operator has the right to mobilize enough military or civilian vehicles to participate in the relief distribution. Here we assume certain parameters in order to make the model. The P we are defined it as the index of type of products, and there could be number of products could be there. And I is the index of the collection centers. Then J is the index of your distribution center, and K is the index for your relief camps, basically. And T, basically small t, we are taking the index of supply turns, because as I said, the number of people may be joining initially at the camp, may move out of the camp. Some new members may also join in the camp, and that is a repeated one. So it can have number of trips on this turn. E is the index of hours, that how many hours for each hour that what is happening. And there we say R subscript KP and T, that means requirement of the Pth relief item at the kth relief camp for the Tth supply term. Delta Kp is unit of Pth relief items required per person. That is basically these many units are required. Ct is the count of people at the relief center at the Tth supply. AE is the total people registered at the relief camp in an hour. Beta A is the total people left the relief camp in an hour. And H is the number of hours between the two consecutive supplies. And T, basically, we are assuming the number of turns to complete or to fulfill the requirement. Then we have AKP. We define it as the total quantity of the PS relief product or item distributed at the relief camp during the interval H. RFJK is the risk factor for transporting items from distribution J to the relief camp K. RF is basically JK is the factor indicating the condition of road from distribution center to the relief camp. DFJK is factor corresponding to the distance between the distribution center J and the relief camp K. And DJK is the distance between the distribution center J to relief camp K. This is a maximum distance, basically MD is the maximum distance set DJK And then we have some operational costs for the collection center, then the distribution center, then the relief center, and that is the maximum budget we have. Then we have some product is going from CC to DC that have to go moving. Then shipping cost, the standard shipping charges from of product P type of product from distribution center to the relief center. And this BJKP is the disaster affected shipping charges for product type P from distribution center to the relief. And then we have a holding cost at collection center, the distribution center, and the relief centers. Now, it comes a disposable charges for a damaged product because we are already in a very pathetic situation. If people are not happy, the environment is not good. So we are having a disposable charges at distribution center as well as the collection center. That how that should be disposed of so that it should not add to the already worse situation. So it has to be taken care of very carefully to and theta and mu are basically the we are just trying to look into the what type of how much portion of the products gets damaged. Then we have a minimum or maximum cost for opening of the collection center, the distribution center. That is basically to operate. Then we have a collected quantity for the relief products P at the collection center. Then availability of the and this availability is basically after removing the damaged or deteriorated products. Same way at a distribution center also we have the same. Then we have a requirement of the particular product at distribution center as well as at the relief centers. And these are the shipping cost basically. And these are the binary variables taking the value 0, 1, basically indicating that whether this is operational or not. If it is not, then 0. If it is operational, that takes the value 1. That is the way we decide because how many distribution center or the collection center or the relief center might be open during this. Yeah, these are all decision variables basically. Now here we try to look into now we getting into your mathematical formulation of this. Now here we have demand estimation of the high frequency product. Now basically these high frequency products nothing but your meal, snack, drinking water, essential medicine. They're all fall under this category. They are high efficiency and that has to be repeatedly keep on moving from this collection center to distribution center and to the relief center for ultimately help to the that is where we are just trying to match here that how this is being calculated. Then we have estimation of low frequency. Here we have a less frequency basically that we are just looking into your sleeping mat, blankets, tents, etc. These are not going to be go for a repeated one. Even the clothing. Excuse me. The initial phase of relief fund key is presented 1 and then that is cost going to be 0. That way it is going to be. Then we have a risk factor. The significant factor influencing the efficiency of the distribution of the relief items are the condition of road connecting the relief camp and transferring depots, distance between the transferring depot and the relief camp, because that is very important. And there what we are trying to look into the pi and xi are the coefficient of the risk factor and the distance factor respectively, and pi 1 minus xi follows the pi 1 minus I and your pi and xi they are lying between 0 and 1 and dfj that is giving you this factor that is defined as the shipping charges and the shipping relief product from distribution center to relief center is being given by this. Now, our ultimate aim is to minimize the total cost of the whole operation. Now, it includes many things. That is operational cost. Naturally, we have to open a collection center, distribution center, as well as relief center. That is inacceptable. Then we have a holding and handling cost of different centers. Then we have a disposable cost of the quantity that is damaged during the operation. Then we have ultimately the shipping cost of the product to the respective centers, maybe from collection center to the distribution center and distribution center to the ultimately relief center. Then we have certain, this is basically my objective function, that how these costs are being calculated. These are operation costs. First is your collection center, then your distribution center, then you have a relief center. This is a holding cost. Now, if you see that we have 1 minus theta, this was the quantity which got damaged. So this is theta quantity got damaged. So 1 minus theta, we have an effective one. Similarly, we have this cost. Here we have a disposable cost. How we are going to dispose of the thing. And here this is your shipping cost. That is from this collection center to distribution center and distribution center to your relief centers. Now we have assigned, because we have a collection centers, we have distribution centers, so we have to look into that how many of distribution centers are connected with the collection center. That is basically assignment between this to this, and this is assignment between the distribution center to the relief center. Capacity of the total quantity available, that is here. This was the total quantity available was QIP or the PS product, but theta got deteriorated or damaged. So effective is available is 1 minus theta of QIP, and that is going to be available this much quantity for the ultimate distribution. The total received quantity from all, so this is going to be this way. Because this quantity is further going to be go to your distribution centers. Here again, whatever the quantity we received, some got deteriorated, the mu times of that, and mu and theta, they are all lying between 0 and 1. So 1 minus mu, that is basically available. This is available to be distributed for the final to the relief centers. And that is where this has to be greater than the requirement. The total quantity received was this. Now, we have already mentioned the C min and C max. That means the minimum number of collection centers to be open and the maximum. The model will determine how many collection centers we need to open. Similarly, how many distribution centers need to be open. So that is where we are trying to look into that, how this is. Then shipping assignment of the collection to the distribution center, that is this way it is going. Shipping assignment or distribution center to distribution to relief center. And that is being defined as this. Assignment to collection center to distribution centers. This is again the same way subject to this. Restriction or decision is operational. That is coming here now. And restriction on RC case if operational. Because that is being determined with the help of your binary variable, which you have already defined, and that helps us. And that is basically integer and positivity constraint, basically. So here, what we are saying, we are considering 4 types of products, and M is there, that is 3. Then collection center is 6, distribution center 6. We are M3, that is collection center, distribution center is 6, the relief centers are 12. And these are the basic input, and then we have alpha beta, all this information, and this is the maximum budget is 65,000. 6,50,000. And these are 12 relief center, and D1, D2, D6, these are from distribution center to the relief center. These are the distances of the relief camp from each distribution center to the relief center. This is basically your input data. And that is basically the prior availability of the different products at the relief camps. That is product all four. This is availability of this. And these are affected people in turn 1, turn 2, turn 3, and turn 1, turn 2, turn 3. That each hour there is a variation in the people, those who are there, and there is a keep on changing in one turn and another turn. That happens subsequently. The total collected units of the products, these are given here. And this is the requirement of the relief centers. All this is for all the products. This is availability of different products at the collection centers. This is the total availability of the products at distribution centers. And that is basically the matrix of the total unit shipped from collection center to the distribution center for all the products. That means C1 is getting from D2 and D3. From C1, D2 and D3 to distribution center is getting. From collection center to D4 and D5. And that is the way that is being distributed to the different centers or distribution center from the collection center. And that is basically product 1, 2, 3. From these four, D2, D3, D4, D5 are being picked up as a distribution centers eventually, and that is the way it got connected with the network. that model has picked up that here the C3 is non-functional, D1 is non-functional, and D6 is non-functional. And the rest all are connected with all the 12 relief centers. They are connected with some distribution center to another. And here we just trying to do some sensitivity analysis on theta and mu, that how this is going to get deteriorated or this happen, then how this my cost is going to increase or decrease. That is becomes me the optimum situation that gives me the shipping cost and all these things. This is just again a different way of presenting your sensitivity analysis on theta and mu, but how it moves, that how the cost also gets affected when we are our deterioration rate or damage rate increases. It is going to be recorded for simultaneously. That is what collectively we trying to look into. So what we have able to achieve during this modeling, that means here the inventory relation model is to address the problem of last mile relief products, which is associated with all this inventory, distribution, disposable, all these are. And we have considered a dynamic demand and supply component. And this doing theory system is being sort of used for the stochastic processes. At the same time, decision-making principle informs the consideration of disaster severity and the risk under uncertainty. Basically, this proposed work we believe will definitely assist your decision maker in designing a fair and efficient relief distribution network by considering assumed factors. Basically. Now, this was the first part that we are trying to look into, that how the relief centers needs to be addressed in that situation when people are very lot of this. Now we are going another one, that is sustainable flow smooth supply chain with multi-phase. Altogether a different scenario, but it also comes under your supply chain. And we also call it as a closed loop means that means whichever many products we are using, and there could be a buyback or we make a product can be reused after some corrections. Okay? And there are certain products that not be used. But this is a historical presentation of the closed loop supply chain. When we have a manufacturing plant and then consumer goes to your retailer and then it goes to ultimate consumer. Then after you, the consumer, return your units yourself. And then collection center just sort of verification or inspection of all these items. And it is in a significant way decide whether that product is remanufactured, that means there might be a silent defect, and that can be used for the after correction. Whether yes, means use after reman. And that product needs to be a reman. And we have assumed that remanufacturing plant works separately than the manufacturing. And there are certain products which have a major difference in the belief that it cannot be manufactured, and then ultimately is sold for the family. Now, here we have assumed the multi-retailer and multi. In today's dynamic business environment, manufacturing is increasingly adopt multi-retailer. As we all look into now day-to-day life, and basically they have a distribution strategies to expand the market reach, getting the customers, to mitigate the risk, push the competition, and enhance supply. Now, what is multi-shipment? This refers to a process of coordinating the delivery of multiple consignments of order, often to a different location, to optimize efficiency, reduce costs, and meet varying delivery. Reducing, ultimately reducing the holding costs and maintaining the availability of the recycling manufactured products by incorporating single order multi. We all see in day-to-day life, but we never experience. We're just trying to do it into a mathematical modeling our system. Now here we will be considering the two approaches. One will be we call it as a cooperative approach. Another is non-cooperative. A cooperative is basically when we focus on the group of players forming coalition to achieve a mutually beneficial outcome. Through negotiation, collective agreement, that is collective decision making where it is beneficial for both. That is what we call it, right? Here we will be looking into two approaches. One is a national bargaining with a fixed strategy, that means which balances the players' interests by negotiating the optimal solution using the manufacturer-led settlement solution. Another is we just combine, that means we call it as an integration. That means combining methods to address complex problems. That means we are jointly optimizing together something integrated between suppliers, manufacturer, and the. Another approach is non-cooperative. Now, in this approach, basically, they are individual strategy where the player acts in their own self-interest without the collaboration of the or forming position. One important non-cooperative game approach which we are considering is respect. But we also call it as a leader follower. It is especially game where one player may be a leader, moves first and then the player follows just after that. Whatever the decision that manufacturer takes, the others are just following him. They don't have their own say, they have their own say only in their decision making rather than in the manufacturer decision. Then we try to look into the Pareto efficiency. Now here, what we are trying to do with the objective, the Pareto efficient solution is the one where no individual can be better off without making at least one other worse off. Because you have to look into that which is the best one, and that we trying to, with the help of the Pareto efficient solution, we are trying to look into that which method is going to be good. Here also the profit sharing benefits both parties, allowing them to negotiate and select a specific Pareto efficient point through mutual agreement. Here, what we are trying, we have thought of and we have done it. We try to examine with the Pareto efficient solution using a fixed selling price, that is a retailer's purchase cost, which is determined based on the solution derived from your integrated or Nash burning or the manufacturer at the stable price. Whatever the retailer's purchase cost is there, we have obtained an integrated Nash equivalent, and that will be used in order to look into the Pareto efficient solution. Now, our objective is to develop a closed-loop supply chain model integrating a multi-retailer distribution with the multi-shipment policy, addressing the price-dependent demand to optimize the supply chain operation. Then we are analyzing cooperative and non-cooperative, and we trying to optimize policies for the manufacturer and as well as for the retailer. And we do the objective, as I just mentioned, determine with the help of Pareto efficient solution which way is good for either manufacturer or the retailer or both. Now, the key considerations which we have looked into, that is environmental sustainability through closed loop supply chain. Now here we have considered the multi-retailer distribution to enhance market reach and mitigate risk, multi-shipment policy to maintain the product freshness and optimize the holding cost, price-dependent demand influencing your consumer behavior and your supply chain decisions. And I have already mentioned the cooperative and the non-cooperative that we are trying to explore here. So this is a flow of goods in any closed loop supply chain. That is a remanufacturer and the manufacturer units coming here, then it is going to the different retailer, and that is going to be distributed, and then ultimately the customer returns it. Then again it goes to the remanufacturing plant, or we get salvage it to, that is ultimately disposing it off the victim. Now here we have certain mutations parameters which we have considered here. Now rate of manufacturing that we are taking it as a P, YM, that is setup cost for the manufacturer. CM is the manufacturing cost for the manufacturer, and ICM is the inventory holding cost per month for the manufacturer. Similarly, we have a different rate for remanufacturing because it has to be lower than the P, because the less number of products, but we have to have some rate by which we are getting the product back and we are trying to remanufacture it. IR is the sort of cost for the remanufacturing. Unique and CR is the mean remanufacturing cost in it. And ICR is the inventory holding cost per month. And beta, which is a fraction of the collected units for remanufacturing, which we have taken it as a random variable with having a PDF of FB. Then, because it comes the retailer, we have considered different retailers. So these are the base demand of the retailer, basically. IRT is basically inventory level of IF retailer at time T. And AIs are the ordering cost of the IF retailer. So I taking values 1 to M, so that goes by. Then ICRI is the inventory holding cost per month of the IF retailer. Then this is a CSP, is basically a shipping cost per shipment. Now TI is the time distribution between the two successive orders for the IF retailer. And that is, we are just saying they are equidistant. T1, T2, T3, and T1. NI is basically the number of shipments of the IF retailer. And that N1 and N2 is being considered here in Malhotra. Then we have certain costs for the collection center, with the cost of collection that is there. Then we have, because we are holding some units at the collection center, so we are bound to incur the inventory holding cost over there. And then we have theta, that is fraction of the IF retailer demand that is returned from the customers, which is again we have considered it as a random variable, and CSL is your salvage cost. Now we have number of decision variables. That means N, which is the number of shipments, T is the cycle length, SM is basically the manufacturer selling price, which eventually is a purchase cost of the retailer. And then SR is basically retailer selling price. Now, here we assume the demand rate is linearly dependent on the retailer's selling price, such as this, because SR is your retailer's selling price. And DOI is basically demand, based demand, and then how this demand is going to be get affected. The product demand rate is always less than the manufacturing or remanufacturing demand rate, that we assume that basically in journal should be there, and that has been mentioned by Hariga et al. In 2017. The manufacturing of the new units began only after the remanufacturing of the return unit has been completed. This assumption is important because we are considering it's a continuous process. So we believe that whenever the remanufacturing products, whichever return is over, then only we start producing the new products, basically. Initially, the demand is fulfilled by the remanufacturing products, as these products we have assumed here is as good as the new one. So after all the remanufactured products have been located, the new manufacturing product fulfills the remaining demand, and that has been also presented or mentioned in the Costa et al. In 2023. Now here we are giving you graphical representation of what is happening. See, we have said that first we are trying to remanufacture the return products, whichever, wherever they are remanufacturable products are there. And then eventually, when that remanufacturing process is over, and here you see that here it is over, but the moment we have made this many products, these are dispatched, then we again continue, and then again we dispatch, and again we continue, and again. And here the remanufacturing process here gets over, and these are the total quantity. So this much quantity is left out, but we have started remanufacturing of the new products. And whatever the left out after the remanufacturing process is over, these are again distributed in a number of shipments to the retailer. And thereafter, it has started shipping from here. And then eventually this here, we stop our production also for the new product. And then this was the inventory left out, and then it is the number of shipments which are going for ultimately to the retail. This is a remanufacturing cycle, which is shown there in a smaller way, and here we are showing it in a little bit broader way for the calculation part that is being shown here, where that makes it easy to calculate the different cost parameters into the when we are writing the objective function. Here, the setup cost for the remanufacturing, because first we have started doing the remanufacturing. So firstly, we are just going to look into the cost components of the remanufacturing cycle basically. And the setup cost is basically IR that we have already mentioned. Then we have a holding cost. So that is basically what we have just shown there. Yes, that is being calculated. These are the area of the triangle ABC. This is ABC. So this is the different triangles which we are taking in trapezium. That is the way we are just calculating the area of trapezium, the area of different trapeziums, and ultimately we are adding them into to get a total inventory holding cost for the remanufacturing cycle basically. So that ultimately comes out to be this. Then cost of remanufacturing that we have calculated here. The revenue generated from the sales, that is basically here we are calculating. And this is a total profit due to the remanufacturing product as follows. That is basically here. Then we look into your manufacturing side. That is basically the setup cost. Then we have a remanufacturing cost, and then ultimately we calculate here in a similar fashion as we have calculated for remanufacturing cycle. Similarly, with the same process, we calculate, and then after simplification, we get this as an inventory holding cost for the manufacturing cycle. Then it is a revenue, and then the total profit function comes out to be this is revenue minus the total cost of the remanufacturing cycle. Now we look into some behavior of the collection team. Because here, after the sales, the people start moving to submit their products for the returning the products, submitting the products in order to get it disposed of in a proper way, rather than just throwing the product into a dustbin that may add a very situation depending upon the product which we are under consideration. So that is where we are just trying to look into this, how these are collected, and then we are trying to sum up here. And then ultimately we calculate the it's a combination of the collection and stealing cost, basically, and cost acquiring due to disposing of a major defective cost. This is your holding cost of this collection center, and which eventually the total cost of the collection center will be summed up here. Now, the total expected profit for the manufacturer, that means combining all the three basically, manufacturing cycle, remanufacturing cycle, and all these they are clubbed here and eventually equated. Now, we look into the inventory behavior of the retailers. For here, we are getting the retailer because he is getting equal shipments for a number of times. At the NTR, where any shipments are coming. So that behavior, we are just trying to calculate because everything has to be mathematically calculated in order to go for joint optimization of things. Yeah, there's a very simple way of having your differential equations, and then after solving these differential equations with the boundary conditions stated out here, you get these are the solution for these inventory differential equations. Then you can collect or write down the cost component of the M retailer. The first is basically we are just adding the all the ordering costs of each retailer. Then we have basically the demand of each retailer, and then we have a purchase cost, which is same as at which they have purchased it from the manufacturer. Then we have a holding cost of each retailer, all the M retailers, one by one, if we just going to look into, and then sum them up all, you get this. Then revenue generated from the sales of this product basically comes here. This is the expected profit of all the retailers. This is the revenue minus your total cost, which is coming from all the retail M retailers. Now we get into this solution approach. That means how do we solve it? Now in a cooperative game, that we have said that we are having some coordination between the manufacturer and the retailers. So we have a two distinct approach, which is basically the integrated and the Nash bargaining solution with the fixed threat, which we call it as. Now, integrated is basically nothing but we are integrating the total, both the profits together. That means we are adding the manufacturer profits as well as the total expected profit of the retailer. We are just combining the two. And collectively, we are just trying to optimize. The N is a discrete because N is the number of shipments. And rest, SM is your selling price, T cycle length, SR is your selling price of the retailer. So we are just trying to optimize this, that how do we get the best solution for this. Now we have posed this little algorithm that through which we are trying to obtain this, and this is a heuristic method which was proposed by B and Law in 2001. What it says that begin with the pick of a discrete variable n. Because n is an integer larger than 1. It has to be greater than equal to 1 because otherwise the model will not work. At least one shipment is required. Then by fixing that, then we take the partial derivative of the total profits with respect to T, SR, and SM, and we are equating them equal to 0 as a necessary condition for optimality. So similarly, for different integer values of n, we just trying to find out your T star, SR star, SM star from this equation. and then substituting it, and ultimately we get the total profit function, which we get from here, which we have just said this. This is the total profit function in the integrated one. Then we trying to find out the maximum of this. We repeat step 2 and 3 for each feasible m numbers that falls between the lower and the higher one. The optimum solution is represented by this. And ultimately we get fixes because it has to satisfy the following criteria. And that this criteria is basically is giving me the optimum value of n. This is a discrete variable which is help us in obtaining the value of a discrete variable, and that the nth replenishment lot size substituting this, and then we get the total cost function. The following sufficient condition must be met for this objective function for the concavity. The optimality requirement is a challenging one to prove mathematically, looking into the kind of expressions and the complicated expressions of the profit function which we have obtained for manufacturer as well as for the retailer. So instead of which is we were finding it very difficult. So what we have tried to do, we have tried to establish the optimality with number of different data sets, and we trying to establish it graphically. And here we just trying to look into that how this is a concave function, or we say convex upward function, that helps us in taking, assuming that what we have done is acceptable position for the moving further. Then we try to look into Nash equilibrium with the fixed thread. Now, here we have two parties, manufacturer as well as the retailer. Here they are cooperating or negotiating, and this is basically, and that is basically Friedman 1986 and about Jaggi 2003. They have used, we have borrowed from there. The Nash bargaining solution, the fixed threat U, is obtained by maximizing with respect to all these parameters. Right, where TPM is for sellers or manufacturers profit function, and TEP is basically for the retailers, represent the manufacturer and the retailer, represent the total. The solution procedure, we follow the same as has been used in the earlier methodology, basically. In the integrated one, the same methodology we have tried to use. That is, then we have a manufacturer-led Steckelberg that is non-cooperative. If the manufacturer leads by setting decisions first with retailers, with retailers react to maximizing their profit. Manufacturer leads by making strategic decisions on shipment and pricing. Retailers purchase cost, because whatever decision the manufacturer takes, that becomes a selling price for the purchase cost for the retailer. Retailers follows responding to the manufacturer decision by maximizing their profit. The manufacturer-led Steckelberg, that is basically now we come to here, that is whatever the maximizing this, then S and P here, and then subject to the constraint, that is T star coming from the seller's point of view, and this is the retailer's point of view. Now this equation derived from the optimum determined by the first order condition, that is just taking the derivative with respect to T and SR. Again, the solution is methodology we have solved for the same, and we have tried to establish it again with the help of the graphical representations of this solution procedure of the Pareto as well. Now it comes to a Pareto. That was for the non-cooperative, and now we come to the Pareto solution. The Pareto efficient solution for manufacturing retail ensures that resources are allocated in a way that no party can improve its outcome without negatively impacting the other. Obviously, when we are connecting with lambda and 1 minus lambda, when lambda is lying between 0 and 1, so that has to be one person's gain, the another's losses is going to be there. That is the way we are trying to find out which is the best way of setting up for this. Now, to maximize that with respect to the manufacturer selling price, assume to take the first order derivative with respect to lambda. To fix the manufacturer selling price through cooperative and non-cooperative solution. To determine the optimum value of SR, N, and T by maximizing Z. And Z is nothing but lambda times TPM of the manufacturer and 1 minus lambda of TPM of retailer. This is the expected profits which you. Then we determine this lambda as this. The solution procedure Pareto efficient solution is identical to that of an integrated. That means that will be same way we are trying to follow the solution approach. And that is basically now we are coming to your numerical example of the same. That means the table here we have P, which was for the manufacturer, then you have a setup cost, then you have your CM cost, manufacturing cost, then you have retailer remanufacturing production rate, then you have setup cost for that, then you have current cost, retailers cost for that, then we have a inventory carrying charge for this per month, then cost for the salvage cost is there, collection cost is there for per unit, and these are the number of 10 retailers we have. This is the basically base demand. This is the demand parameters, which is connecting with your selling price. This is the ordering cost of each retailer. This is which you have taken as a inventory carrying charge. For all this is a fraction. Theta, that means how much products are coming back. That is where we have assumed here. Now, firstly, we solve this with this data, manufacturer cycle approach. Then we use it for Nash. Then we use for integrator. If we just look into these, then we are not able to take a decision which way we should go. At here, this if manufacturer is better doing, retailers are not doing better. Here, retailers are doing better. That means in Nash, manufacturer is not doing better. Here again, the integrator also, retailers are doing better as compared to others. Now, we are trying to look into from the Pareto efficient solution, now what is happening? No doubt, here it was doing better, but with the Pareto solution of the manufacturer led, what we have looked into, this has improved. Again, if you have objective of the manufacturer, this is a better one. And if you look at this as also, so it is giving beneficial to both for the Pareto. Now, if we look into the Nash equilibrium and the Pareto efficient, what it says, this has reduced the retailers and manufacturers' profit has gone up as compared to the simple Nash equilibrium approach. Integrated one, again, when we look into this Pareto, this has reduced, this has increased. The total profit which we look into, that comes out over this, because combining the two. Here again, we trying to look into where we want to go. If we have objective for the retailers, then this way is better or this is. If you have manufacturer led, then it is. This is already a manufacturer led, so that means definitely the manufacturer has a say over the others. What we say, the integrated approach, if you use highest total system profit at this monthly, optimizing the supply chain. Nash bargaining solution with a fixed rate has the maximum retailer's profit monthly with the total profit of this, which is slightly lower than the integrated one. Manufacturer led, which is having a manufacturer profit like this monthly, total is it. This is compromising the overall system efficiency basically here. Now we try to do some sensitivity analysis on this. That means if we are keep on changing the holding cost, the manufacturer holding charges, if we increase or decrease, then ultimately that's how which model is going to behave. That is basically depicted. Because if you increase holding costs, your profit goes down, which is some percentage, and otherwise this is going to go up. Now, this is natural phenomena. Even the shipping cost goes up, then again, logical result are there. If it is going up, naturally your profit, the cost is going up, naturally your profit is going to go down. And if it is going down, naturally your profit is going to go up. The fraction of return units, if this goes increases, your profit is going down. And it is coming, then it is your profit. Now, what it suggests is basically if it is going, it means your products which are coming back are having very minor defects that needs to be looked at so that it can be taken care of in the freshly products. That gives the indication basically to do that. In the remanufacturing units, which again that is coming out to it, and that becomes infeasible here. When this base demand goes and this is not feasible, yeah, demand parameter, if it is going up by 50%, then also it is not feasible solution. Now, what we can say here is the decreasing holding charges may result in fewer shipments, lower retailer price, longer cycle, and potentially the higher profits. As the shipment cost decreases, the number of shipment goes up naturally, that is logical, while the cycle length and the selling price decreases, leading to the higher total expected profit. Frequent shipments take advantage of reducing shipment costs, lowering holding costs for manufacturer and the retailer, ultimately, which improves your overall system profitability. Naturally, as the return unit increases, the shipment cost, cycle length, and profit moves upward. However, there is a drop in price, making returns beneficial for the product and efficiency. When the remanufacturability of the return unit increases, cycle length, shipment, total profit rises, while the selling price decreases due to reduced wastage. Base demand, again the same then, if it goes up, then it adds up in the higher profit. As the demand parameter AI increases, the product selling price decreases, leading to a reduction in both demand and the profit. To counterbalance the higher demand, the model adjusts by lowering the product price, stimulating demand response and mitigating the negative impact on the profitability. Ultimately, this is the conclusion which we can get. The closed loop model strengthened by a multi-shipment policy, optimizing your remanufacturing and reducing waste, improving the profit and the ecological sustainability. Cooperative approaches, integrated equilibrium, balanced profit, optimizes demand and reduces in conflicts of the long-term stability. Pareto solution naturally helps us in looking into the best way of taking a decision, which way one should go for. The model optimizes the selling price, shipment, and cycle length to maximize profit, an integrated approach showing the best performance result despite the trade-off. Remanufacturing improves the supply chain, reduces the production cost, lowering holding costs, promotes sustainability by minimizing the waste. That is what we could say. Thank you for your patient. You. Thank you for your time, for all the participants.
Thank you, sir, for the insightful session you conducted on supply chain optimization. Your expertise and clarity in explaining complex models like an inventory release chain model and humanitarian and retail supply chain model that includes complex big mathematical equations, integration and everything, the complex equations, your expertise has made that topic very engaging and easy to understand. And definitely, all the participants feel fortunate to have had the opportunity to learn from you, sir. Thank you once again for your time and effort in making this session so valuable. Thank you so much, sir.
Thank you. Thank you, Gaurav. Thank you so much.
Gaurav sir, I'll take a moment to pay gratitude to sir.
Yeah, sure, ma'am.
Sir, it's an honor and privilege to have a session with you and to learn from someone with such vast experience and depth of knowledge. I would like to sincerely thank you for your time, effort, and willingness to share your wealth of knowledge with us. We are fortunate to have benefited from your guidance. Thank you,
Thank
sir.
you. Thank you. Thank you, Mamta. God bless you. Keep moving upward. All the best. God bless you.
Thank you, sir.
Dear participants, we will be starting the next session very soon.
May I leave?
Yes, sir, you can leave, sir.
Thank you.
Thanks a lot, sir. Our next session is on feature selection technique for data analysis using Python. A resource person is joining soon. Stay tuned with us. We will be starting the session in next 5 minutes. Please be there in Zoom meeting. Okay. Meanwhile, we all can turn on our camera and take a group picture. I request all the participants to switch on their camera. We need to take a group picture. I request all the participants to switch on their camera. We need to take group picture. Thank you, everyone. So we are starting with our next session. Ma'am is here. The topic of next session is feature selection techniques for data analysis using Python. The session will be taken by Dr. Kavita Khanna. Dr. Kavita Khanna has teaching, research, and administrative experience of more than 24 years. Her areas of interest includes artificial neural networks, machine learning, design and analysis of algorithms and data structures. She has more than 50 publications in reputed journals and conferences. She has guided 20 MTech and 5 PhD students in their research work. She has completed various research projects and multiple consultancy assignments with various government organizations, including Department of Science and Technology, National Technical Research Organization, and National Commission for Women. Apart from her academic achievements, she has pursued her passion for music and people while working as a radio jockey with AIR FM Gold for around 16 years. Her articles on upcoming technologies and teaching pedagogies have been published with leading newspapers and magazines. Currently, she is working as the Director, Admissions and Examinations at the South Asian University. Prior to her current role, she has been the campus director at Delhi Skill and Entrepreneurship University, Dwarka campus. Now, I request ma'am to take the session.
Thanks, Gaurav. Thank you for a wonderful introduction, and I welcome all the participants to this session. I hope you have I'll be assuming certain things that you have done in this faculty development program, and I'll be talking about the various feature selection techniques that are very, very relevant to the machine learning model. So whatever machine learning, as you all know, machine learning is something that has become the essence of everything now. Essence of every stream, I should say, whether you, irrespective of the stream that you belong to, whether you belong to computer science or not. But I think efficiency in data sciences, machine learning, deep learning has become the key, and has become so much necessary for everybody. And on that perspective, I've taken up this session wherein I'll be talking about various machine learning techniques, various feature selection techniques that are used in machine learning. So basically, what the machine learning is, I hope, I mean, this is quite a common term now. But machine learning, what happens is, to a machine, you give some data, and the data is in form of certain features. If I talk about deep learning techniques, so deep learning is something wherein the machine itself extracts the features. But for a simple machine learning model, and there are so many applications wherein machine learning works, but deep learning does not work. So for a machine learning model to work, you need to provide the data, you need to provide the features of the data. And that makes feature extraction very, very important domain in terms of if you are using any machine learning algorithm. So let me share my PPT with you, and let us start. So if you can let me know that my screen is visible.
Yes, ma'am, screen is visible.
Great. So as I told you, the relevance of okay. So I start with this machine learning models work. Yes, they do work, everybody knows. But the brute force fact that they work could be bringing us to a new understanding, experience of what the word is and our role in it. Yes, actually, the artificial with the coming in of so much of AI in everything. At times, we feel that what is our role in it? And the latest platforms of based on large language models, when you see those platforms, when you see the things, everything is so magical, and you really feel that what is your role into it. But I always believe that human beings are so capable that human beings can create thousands of machines, but thousands of machines cannot create one human being. So that ways the power of human beings is much more, but at times, yes, the magical thing that comes with AI is something that is very, very amazing, that at the click of the button, you can do so many things. And the word is a black box full of extreme specificity. It might be predictable, but that doesn't mean it is understandable. So yes, when I think those who made ChatGPT or large language models, whatever, every time what it does is a magic, and at times it is not understandable onto what it is doing. Now, what is feature selection? I come over to the topic of feature selection. What is feature selection? Feature selection is the process of reducing the number of input variables to reduce the computational cost of modeling and also to improve the performance of the model. Now we have a data. That data needs to be provided to the machine. So if we provide irrelevant and redundant data to the machine, obviously machine would take more time to train, more time to give the results, and the results may not be that appropriate also. So whatever input we are giving to a machine learning model, that must be very, very specific, must be good, must be not be redundant, must be related to the output. So it should not have the noise. So these are the things that you need to consider when you are giving some input to the machine learning model. So basically, the feature selection technique is the process of selecting the subset of the features which are used for training a machine learning model. I hope you understand the basic schema of a machine learning model, that you feed the machine learning model with a data set. Machine learning model does something, gives the output. Then you find out how that output is based on based on the error that you see. Then you figure out how the various parameters in the machine learning model need to be trained. So how you train those models, that depends, train those parameters, so that depends, varies from algorithm to algorithm, what is the optimization algorithm that you are using. So as of now, I'll be touching one aspect of this, that is, to a machine learning model you are supplying some set of features, and how to extract the meaningful features out of it so that my machine learning model performs better. So it is like in real life. If we are a human being, if we are given so much of input, so much of noises, so much of things are coming to me, I'll not be able to perform well. But if some clear things are coming to me without noise, and they are related to what I am talking about, then I'll be able to make more sense out of it and would be able to perform better. So this compares to a real life scenario as well. Now, what feature selection is not? Basically, at times, feature selection is confused with or mixed with feature extraction or feature engineering. Now, feature extraction, as the name says, you need to extract the features from the data. Or feature engineering, again, the same thing. So it creates new features from the existing features of the raw data. Whatever your raw data is, you create new features like principal component analysis. They create new features. And you use domain knowledge to extract useful information from the data. It gives more features than the original. Should be used prior to feature selection. So you should extract the features first, and then from those features, you need to extract the more meaningful features that would be more relevant to the model. So the first step is to have the features, a big data, when a big set, and from that big set, you reduce it to a subset which is more relevant, which is going to give me good results for the machine learning model. And it is not dimensionality reduction. Dimensionality reduction, at times feature selection is, confused with the dimensionality reduction also, but it is not dimensionality reduction. It creates, when dimensionality reduction, what it does is it creates projection of original features into a fewer dimensional space, creating a new set of features. In case of dimensionality reduction, you basically reduce the dimensions, but while reducing the dimension, the output that you get is not a subset of the given set. You derive the new output. You derive the new set of features. So that is feature selection. In case of feature selection, whatever features you select are a subset of the given original feature set. Whereas in case of dimensionality reduction, it is not like that. Now, what is the need of feature selection? Obviously, it is going to remove the irrelevant features that are there in the data. Accuracy, it would improve the accuracy of my model. It would avoid the curse of dimensionality and overfitting. Now, what is this term? Very, very common used in machine learning, curse of dimensionality. Curse of dimensionality is as the number of features increase. ऐसा नहीं है कि हम if we give machine learning model with more data, it is when more number of features, it would perform better. No, the whatever we are giving, that should be relevant. And curse of dimensionality says the same thing, that more the number of dimensions come into picture, the model would deteriorate its performance and may also overfit. Obviously, with the relevant features, it is easier to build and understand the model that you are making on. It makes the training faster. आपका काम जल्दी होगा अगर आपके पास सिर्फ relevant information होगी तो. Increases the model's performance. If you feed as is the input, as is the output. जैसी input जाएगी वैसी आएगी, and if you give it relevant things, it is going to give you a better performance. So this is the need of feature selection, why it was there, because feature engineering and feature selection is a separate topic in machine learning, and it's a huge topic. Now I talk about the types of feature selection. If I talk about the types of feature selection, there are three types: filter-based approaches, wrapper approaches, and embedded approaches. Now, what are filter-based approaches? If I talk about the examples of filter-based approaches, they are Pearson correlation, chi-square, ANOVA. If I talk about wrapper-based approaches, you have forward feature selection, you have backward feature selection, and you have bio-inspired feature selection. Then the third one is embedded, regularization and random forest. So as I told you, this is a huge topic with a lot of things coming in, but in this session, I would try to, help you understand the basic process and the basic coding that you can do to find out the features for filter and wrapper-based approaches. Now, what is the filter-based method? As I shared, you have three types: filter, wrapper, and embedded. So filter-based method is what? Filter-based methods are based on basically applying any statistical method. You apply any statistical method to the given set of features. You have a bigger set of features. You apply some statistical model into it and assign a score to each feature. तो हर feature को आप एक score दे देंगे with which comes with the statistical thing. So as you can see, if you see on the left hand side of the screen, there are equal sized balls initially. These are the features. And after that, you assign them with the rank. So the fatter one has more rank and the thinner one has a lesser rank. And I then pick the features which have more rank. So based on the ranking of the features, I'll pick the features into the subset of my feature selection model. So it is basically set all the features, select the best subset, जो भी आपको best subset लग रहा है, and how best this is decided based on any statistical measure that you use. So it also depends on what type of data it is, whether it is categorical data or you have a simple data regression. Now after selecting the features, best features, then you feed these features to the learning algorithm, and then you find out the performance of the learning algorithm. So here, excuse me. So here, the learning algorithm, the machine learning model, is not involved in the feature selection process. As you can see, यहाँ पे जो learning algorithm है, उसको सिर्फ subset of features is given as input. It is not involved at all in feature selection process. So ये दोनों are totally excluded. Feature selection does some work of feature selection, and the whatever the output you get from the feature selection model, you feed that to the learning algorithm and you compare the performance of the learning algorithm. The learning algorithm has no role to play in the selection of the features. The features are selected by a separate thing, and that is with some statistical measure. So this is the relevance of meaning of filter methods. Now I'll talk about one, but before moving on to another type of the type of filter method, I'll talk about wrapper method. Now what is a wrapper method? Wrapper method is, here the feature selection process is based on a specific machine learning algorithm. So machine learning algorithm here is involved in the generation of the feature subset. जो feature set मुझे चाहिए, my machine learning model would also help me identify that subset of the features. And it follows a greedy search approach by evaluating all the possible combinations of features against the evaluation criteria. So इसमें क्या होगा? You have a data set with multiple features, and you have a machine learning model. So firstly, per se, you give one feature as input to the model, and then you see the performance. Then you give two features as an input to the model, and then you see the performance. Then you take three features, and then you feed to the machine learning model, and then see the performance. So for all, say per se, you have 10 features. So one by one, you may increase the feature set and then feed it to the model, and then see what is the result that is coming. And so here the machine learning model is contributing in finding out the best set of features. And this is a greedy approach, as you must be knowing. And the evaluation criteria would be how the learning algorithm is performing. So performance can be based on, multiple criteria can be used for the performance testing for, when you feed the learning algorithm with the subset of the features. So here, as you see that the machine learning algorithm is a part of, feature subset generation. And then you get the best features. You get the set of features. Now, this set of features is fed to the next machine learning model. So now the next machine learning model can be the same that is being used in the feature selection, or can be different also. So here, one machine learning model is used to find out the most relevant features. You get the feature subset which are the most appropriate for this specific model, and then you give this as an input to your basic machine learning model that next you are using. So next machine learning model that you use may be the same that you have used for your feature selection process, or maybe different. So this is the crux about the repo methods. And embedded methods use both the things. Now, if I talk about some filter-based approaches, as I shared here, Pearson correlation, chi-square, ANOVA. So basically, I hope you must have heard these names when I talk about Pearson correlation, chi-square, or ANOVA. These are statistical techniques. And as I told you that in case of filter-based approaches, you assign a rank to every feature. And that rank is based on your any statistical technique. So maybe Pearson correlation, maybe chi-square, or maybe ANOVA. So these are the three filter-based approaches that are being used. Now, if I talk about chi-square test, I hope some of you must have used it. So the chi-square test is used for categorical features in a data set. So if you have a categorical data set, means if your the output of it is belongs to some category per se. If I want to have I'm given a data set and I want to classify whether these mails are spam or not spam, so I have just two categories for the output. That is my categorical data set. And if I say ki, the output can be anything, it does not belong to a fixed set, then that is the other type of data set, and that is not the categorical one. Now, how do we calculate chi-square between each feature? We calculate chi-square between each feature and the target, and select the desired number of features with the best chi-square score. So here chi-square हम किसका निकाल रहे हैं? We are finding out the chi-square between each of the feature and the target. So suppose you have 10 features. So you'll find out the chi-square value of first feature with the target, second feature with the target, third feature with the target, likewise for all features. And then you see which has the highest value. And this is the formula of finding out the chi-square. That is your observed value minus expected value whole square upon expected value. Observed value minus expected value whole square upon expected value, and you sum all this to get the chi-square value. I'll take a Python session for all the techniques that I'm sharing with you. So first part is I'll take up theoretically, and then I'll move to the Jupyter notebook to demonstrate all these techniques in Python. Now, if I talk about correlation coefficient, I hope you have heard about this also, very, very basic. But yeah, very basic techniques do wonders in machine learning. It's the measure of relationship between two variables, and the basic formula that I hope you all must have seen. And if R is 0, that means there is no correlation. And if R is +1 or -1, there is high correlation, either on the positive side or on the negative side. That means they're totally linearly dependent. So the idea here is features should be correlated with the target, but should be uncorrelated among themselves. So यहाँ पे हम क्या करेंगे? We will find out that how the feature is related with the target, but also we'll find out how the features are correlated with themselves. Now, if there are two features that are very strongly correlated, so then in that case, I don't need those two features. I can use one of them only because they have a strong correlation. They have a same behavior. तो अगर दो चीजों का behavior same है, so I can pick one of them and I can discard the other. How to pick one of them? The one which would have a stronger correlation with the output. I'll pick that. So that way, if two features are correlated, the model only really needs one of them. So if we find that the predictor variables are correlated among themselves, we can drop the variable which has a lower correlation coefficient value with the target variable. So if you have two features which are correlated, I don't need both of them. I'll find out the correlation of those two features with the target, and whosoever has the more correlation with the target, I'll take that. So that is the basic crux of, these two chi-square test and correlation coefficient, how they work. Now, if I talk about the benefits of filter approaches, obviously they are less expensive, they are simpler. A machine learning model is not involved here. So here you are just applying statistical technique to find out the rank of the feature. So they are computationally less expensive, works well with the voluminous databases. Even if you have a larger database, it works well. Lower risk of overfitting. This approach would not have much risk of the overfitting into the model. So I hope you understand overfitting. Overfitting is when your training data gives good results on the machine learning model. But when your model sees a new data, आपने जो ट्रेनिंग कराई, जिस डेटा पे कराई, मॉडल उस पर बहुत अच्छा रिजल्ट दे रहा है, बट जब मॉडल को नया डेटा दिया तो मॉडल रिजल्ट अच्छा नहीं दे रहा. सो दैट इज माय overfitting. So basically the model tries to fit more into your training data, so it is then not generalizable. So but in case of this filter based approaches, they have a lower risk of overfitting. Then it easily scale on a high dimensional data sets. So if you have higher dimensions, you increase the dimensions, then you can scale up on this. Now, if I talk about the limitations of filter approaches, it ignores the interaction with the classifier. तो जो भी आप क्लासिफायर बाद में यूज करने वाले हैं, मशीन लर्निंग मॉडल जो भी यूज करने वाले हैं, these filter approaches, they'll not, they totally ignore whatever model is being used. They are totally exclusive. Then it does not consider dependency of one feature over the other. So most of these do not consider how one feature is depending on the other. Then can miss some features that are not useful by themselves, but can be useful when combined with others. So there may be the case that some feature doesn't seem to be, much useful individually, but when it is combined with something, then it gets useful. So filter-based approaches see the features in their individuality, not in the combination of the features. So that is their limitation. Now, this I already shared. What is a repo-based approach? I hope you'll be able to make out more sense out of this figure now. When I say that you have a set of features, you generate how the subset is being generated, you generate a subset, feed it to the learning algorithm, see the results, you repeat this process until you get an optimal set of features. And this process, you can see that it is getting repeated till you get the best subset of the features. And that best subset, how it is determined by some performance measure of the learning algorithm. Now, how do we select the features? How this iteration is happening? As you can see, there is one loop happening here. Now, how this is happening? So there are two ways in which we can do it. One is the forward selection and one is the backward elimination. Forward selection is, suppose we have 10 features in my data set. We start with having no feature in the model. And in each iteration, we keep adding one feature at a time. At every iteration, I add one more feature to it, and then I see how my model would perform. So that is forward selection. At every step, I'm increasing my size of my feature set and then seeing the performance. So now with this, we keep adding the features which best improves our model till an addition of a new variable does not improve the performance of the model. So if I add something and it is not giving me the good result, then I'll discard adding that feature. So that ways we get this best subset of the features in case of forward selection. In case of backward elimination, we start with all the features. So I have the complete feature set, say 10 features. I start with 10 features. I give my model the input as 10 features. And then I remove the least significant features at each iteration. क्या रिमूव करने से मॉडल बेटर परफॉर्म करेगा, सो दैट इज बीइंग सीन एंड देन द फीचर्स आर रिमूव्ड दैट वेज एंड वी रिपीट दिस until no improvement is observed on removal of the features. So that ways we iterate in case of backward elimination. If I talk about the benefits of wrapper approaches, it has better generalization than filter approaches. They generalize well. Then considers dependencies among the features. आपस में features की dependencies को consider करते हैं. Then classifier interaction for selecting features. Obviously, you have a classifier here and your features are being selected in consultation with the classifier. Then finds the most useful features. And then what are the limitations? Obviously, you are using a machine learning model. Every time you are feeding it with some input, finding out the performance, then feed with the other subset, and then find the performance. So it is more computationally complex. Execution time is going to increase, and it is prone to overfitting on a small training data set. So it can overfit on the data that training data that I provide if the data is less. So it can go into overfitting. So requires greater computational resources also if you have more data then and more computational complexity. Less scalable for large data sets. बिकॉज आप मशीन लर्निंग मॉडल में दे रहे हैं वहां पे क्या है आप सिर्फ आउटपुट से कंपेयर कर रहे हैं सो दे आर मोर स्केलेबल फिल्टर बेस्ड अप्रोचेस रैपर बेस्ड अप्रोचेस आर नॉट दैट स्केलेबल एंड हियर वॉट एवर सिलेक्शन यू आर डूइंग इज क्लासीफायर डिपेंडेंट अब आप कौन सा क्लासीफायर चूज कर रहे हैं on that it would depend upon what type of feature subset you get. Now coming on to the final difference of the filter versus wrapper approaches. Filter methods, they measure the relevance of features by their correlation with dependent variable, while wrapper methods measure the usefulness of a subset of features by actually training a model on it. So as I told earlier, that wrapper-based approaches, they do actual training in figuring out what would be the best subset, whereas filter methods, they measure the relevance of features by their correlation with the dependent variable. Filter methods are much faster as compared to wrapper methods as they do not involve training the model, whereas wrapper methods are computationally very expensive since they involve training the machine learning model. Now, if I talk about filter methods, they use statistical methods for evaluation, while wrapper methods use cross-validation. So, जो भी हम evaluation करते हैं यहाँ पर statistical method से करते हैं. In case of wrapper method, we use cross-validation. Then filter methods might fail to find the best subset of features in many occasions, but wrapper methods can always provide the best subset of features. As I told that since they do not consider the correlation of the features among themselves, or they consider them in their individuality, when two features combine, they may be more relevant. So filter based approaches ignore all such things. So in that case, they may fail to find the best subset of the features. But wrapper methods, they'll always provide the best subset of features. Now, using the subset of features from the wrapper method make the model more prone to overfitting as compared to the filter-based approaches. Since in case of wrapper-based approaches, the machine learning model itself is involved, so they are more prone to overfitting than your filter-based approaches. So this is all about the theory part of the feature selection techniques. As I told you, I'll be covering the filter and the wrapper-based approaches. And I'll be now taking you into the demonstration part of some filter and wrapper-based approaches. So till this point, if you have any doubts, you can ask. If then I may move to the hands-on session in Python. So anyone having any doubt may please ask, or may I move to the hands-on session? We see some message has come. Not able to see. I'm sorry for a bad throat and cough today. Okay, so I now move to this. These are some of the Jupyter sheets that I've created for. So I'll be using Collab. So I hope you must have heard about Google Collab. So Google Colab basically gives you a platform for running the Jupyter notebooks and gives you a wonderful platform to execute your Python code. If you are not familiar with this, I'll share some of the features, how it works. So this is your, if you have used Jupyter notebooks, it is almost same as using a Jupyter notebook on your own system. So on your own machine, you use Anaconda to work on Jupyter notebooks. But at times, using it on your own machine, it may not be good for a bigger data set or, bigger models, deep learning models, which require more computation. So Google Colab is basically, they are GPU based also. So जहां पर भी आपको कंप्यूटेशन पावर चाहिए होगी, so Google Colabs work really well क्योंकि आपकी मशीन पे सिर्फ आपकी मशीन की पावर यूज होगी. So here you can use, cloud-based platform of Google Colab and use their resources as well. So the first is chi-square test feature selection. Now, chi-square test feature selection, as I told you, you find out the chi-square score of each feature. Now, this is my Google Colab window, how it looks like. You have a file, you have edit, you have view, insert, runtime tools. So basically, you will have a cell here. The cell can have a code type or a text type. So text is when you want to put anything as a text, and code type is when you want to enter code into it. So I've created this Jupyter notebook, and you can see here you have a run button. So either you can press Control Enter or Alt Enter. Alt Enter say you get a next empty cell, and Control Enter just executes this current cell. And another way is you just press here Run Cell. If I run, it would run. So now these are the important necessary libraries that I need for my feature selection. I would be needing NumPy, import NumPy as NP, as NP is when you are aliasing it, that you are giving it a short name. बार बार NumPy लिखना पड़ेगा, तो इसीलिए उसको एक cute सा छोटा सा नाम दे दिया, that is NP. Then import pandas as PD. Then from sklearn.feature selection, sklearn.feature selection is a module, is a feature selection module in Python, and it provides you basically various methods for feature selection. So sklearn feature selection I'll be using, and sklearn feature selection, as I told you, is a Python library. sklearn is a Python library, and feature selection is a sklearn feature selection is a module in the sklearn library. Then from this, I'll import select kbest. Now select kbest क्या है? ये एक method है, या ये कहें कि ये class है scikit-learn में, which would help me finding out the kbest features. Then I am also importing chi2, which is basically for chi-square test. So all Python gives you so much of functionality with its, so many frameworks being given. So and libraries, so NumPy, Pandas, sklearn, I'm using all these three libraries here. Then from sklearn pre-processing, I am importing min-max scalar. So I'll be sharing with you the use of each one of these. So I've executed this first code block, and then I come to this second code block, which is example dataset. एक dataset, obviously you have to feed your model with the dataset. अब dataset आप खुद क्रिएट कर लिख सकते हैं, कोई डेटा सेट इंपोर्ट कर सकते हैं. So I've taken two examples. In one example, I'll be importing one data set wherein I'll show you how to import a data set. And here I have created a data set in the form of a dictionary. So dictionaries, you have key value pairs. This is my key, feature 1, and it has value as this array. Then feature 2, it has value as this. So as you can see, there are 3 features, and one is somebody has said that camera is not working or what? Can somebody please tell what is the problem? Is my screen, Python screen, visible to all of you?
Yes, ma'am, it is visible.
Okay, well, thank you. So I have 3 features you can see, and I have one target, that is the target value, binary target. Now, this is in the form of a dictionary, as you can see, जो Python में ये एक dictionary है. अब इस dictionary को I'll convert it into a data frame, and if I execute it, I want it in the form of a pandas data frame, and the function that I used is pd.dataframe, convert to a data frame. अब जिसको data frame में convert करना है, that I'll pass to this function data, and I'll store it in df. Now if I print df, this is what my data set looks like. I've taken a very small data set here just to make you understand the concept. So I have this feature 1, feature 2, feature 3, and this is my target. So ये एक मेरा छोटा सा डेटा सेट है. अब इसमें से मुझे देखना है कि कौन से मैं आई वांट टू से कि मैं 2 रेलेवेंट फीचर्स लूंगी और फिर मैं देखूंगी कि कैसा लगता है, कौन से वो 2 फीचर्स होंगे. अब ये जो मेरा डेटा सेट है, आई नीड टू डू सम tweaking. I need features separate, and I want my target to be separate. Because I want to work on feature 1, feature 2, feature 3 only. I want to work on first 3 columns, and this target, I want to find out the subset of features based on the target. So I want to separate these 2 things. So what I'll do is, सबसे पहले let us check how many values are there in feature 3. In feature 3, 1, 2, 1, 2, 1. This is a categorical variable. ये categories है 1, 2, 1, 2. अब categorical, ये जो भी काई स्क्वायर मैंने आपको बताया या जो मैंने दूसरा भी बताया, टारगेट कैटेगोरिकल होगा, बट कोई भी फीचर जो है वो न्यूमेरिकल होगा. सो इफ देर इज सम फीचर विच इज कैटेगोरिकल, देन आई नीड टू कन्वर्ट इट टू इट्स कॉरस्पॉन्डिंग, आई नीड टू गिव सम कोड टू इट. देन तो सपोज यहाँ पर 1, 2 की बजाय ट्रू फॉल्स होता, या यहाँ पर फीचर 3 कुछ होता से सिक और पर से क्लास मेंशन कर देते, क्लास 1, क्लास 2, क्लास 1, क्लास 2, क्लास 1. सो ये मेरा क्या हो गया, कैटेगोरिकल फीचर हो गया. बट जो भी मेरा काई स्क्वायर मॉडल है, वो जब फीचर सिलेक्ट करता है तो वो न्यूमेरिकल डेटा पे करता है. सो व्हाट आई कैन डू इन दिस केस, क्योंकि ऐसा तो डेटा सेट होगा जिसमें कुछ आपके कैटेगोरिकल फीचर्स होंगे. सो आप क्या करेंगे उस केस में, इसको 1 हॉट एनकोडिंग करें. 1 हॉट एनकोडिंग इज यू गिव अ कोड टू योर फीचर्स, कि जैसे 1 है उसको मैं कोड दे दूं 1, 0, जो 2 है उसको मैं कोड दे दूं 0, 1. So I need to encode my features, and that is done with the help of a very one-liner function, that is get dummies. Get dummies use करके हम categorical features को 1 hot encoding फॉर्म में लिख सकते हैं. वी कैन गिव कोड्स टू दीज फीचर्स बेसिकली. सो अभी मैंने देखा इस फीचर 3 में मेरी टोटल कितनी डिस्टिंक्ट वैल्यूज है, एंड इट टेल्स मी कि 1 की कितनी वैल्यूज है 3 और 2 की कितनी है 2 वैल्यूज है. सो इसमें डिस्टिंक्ट कितनी थी, 2 थी, 1 और 2. और 1 is repeated how many times, 3 times, and 2 is repeated 2 times. अब मैं इसका अगर साइज देखना चाहूँ तो df dot size, and you can check what size your data frame is. So we need to run it once more. Okay, so there are 20 elements in it, and if I need to see the shape of it, I can use df dot shape, and it is going to give me, it has 5 rows and 4 columns. As you could have seen also, if I remove this and print just df, so it has 5 rows. You can check 0 to 4, 5 rows and 4 columns. Now my first purpose would be to separate the features and the target. So whatever in most of the cases, you would have a complete data set. So you'll separate the target and you will separate the features. Now how we do that? You just need to simply firstly drop the last column को drop करेंगे, बाकी जो बचा है उसको x में स्टोर कर लेंगे, और जो लास्ट कॉलम है उसको y में स्टोर कर लेंगे. वेरी सिंपल. सो df was योर फ्रेम. आप इसको एक्सेल की तरह इमेजिन कर सकते हैं कि एक मेरे पास I have one Excel sheet like your multiple columns, your multiple rows, and I drop this target. I drop this x is equal to 1 specifies that it is a column. If I write x is equals to 0, then it would drop a particular row. So I drop the target, the last column, x is equal to 1, the target, and then store it in x. And then I consider this column, target column in the data frame, and then store it in y. So now if you see what is your x, if I print x, you see x would have feature 1, feature 2, feature 3 only. And if you want to see y, oh, it was a small y, it wasn't a capital one. So you can see that it now has target 0, 1, 0, 1, whatever the target values were. So with this step, I have separated my features and I have separated my output target variable. So there's no need to display. And then I come over to, as I told you that this feature 3 is categorical feature. So I need to convert it to some code. I'll give it a numerical code. And how to do that? Get dummies is a function that you use here, is a method. Get dummies, pd dot get dummies. Pandas mein it gives you gives you this method get dummies, which basically helps you to give you the codes of whatever you want. तो गेट डमीज को हमें क्या इनपुट देना है, एक्स इनपुट देना है. किसके डमीज क्रिएट करने हैं, कॉलम इक्वल टू फीचर 3, एंड डेटा टाइप किस टाइप के हमें क्रिएट करने हैं, इंटीजर टाइप. सो डेटा टाइप इक्वल्स टू इंट. अब इसको डिस्प्ले करना है, इसको स्टोर करा एक्स में. इफ आई डिस्प्ले इट, आई विल गेट दिस. नाउ फीचर 3 वुड बी स्प्लिटेड इनटू 2 कॉलम्स. फीचर 3 1, feature 3 2, 3 underscore 1, 3 underscore 2. And you can see initially for feature 3 the first value was 1, so it has given it a code 1 and then 0. Second में 2 था तो 0 1 1 0 likewise. और अगर मैं यहाँ डेटा टाइप हटा दूंगी तो ये ट्रू और फॉल्स में वैल्यू देगा. So if I share with you, there has been some, let me, wait. So pd.getDummies column equal to feature 3. And I think there has been some error. It is game one hot encode feature 3. And let me then write d type equal to int. So there has been some problem. I'll identify it. After that, what you do, you use min max scaler to scale the features to the range 0 1. अब बहुत इंपॉर्टेंट होता है ये किसी भी मशीन लर्निंग मॉडल में कि हमारे जो फीचर्स हैं उनकी स्केलिंग ठीक से हो. दे शुड बी इधर नॉर्मलाइज्ड और स्टैंडर्डाइज्ड. फीचर को हमें या तो नॉर्मलाइज करना पड़ता है या हमें फीचर को स्टैंडर्डाइज करना पड़ता है. आपने मैथमेटिक्स में कभी ये कॉन्सेप्ट पढ़ा होगा. Standardization is done with the help of your formula x minus mean upon standard deviation, x minus mu upon sigma. So you normalize basically your data with that. And if I talk about standardization, तो standardization में हम क्या करते हैं? You basically squash your entire data and put it in the range 0 to 1. The range that you take for your data gets to be 0 to 1. तो आप अपने डेटा सेट को किस में कर लेते हैं? 0 to 1 में कन्वर्ट कर लेते हैं. सो आपके जैसे अब हमारा ये डेटा सेट था, इसमें वैल्यूज जो है फीचर 1 जो है वो 5 तक ही लेके जा रहा है मैक्सिमम, और फीचर 2 जो है it is taking, it starts from 20, so it has a higher range. So in that case मॉडल की परफॉर्मेंस जो होती है वो डिटेरियोरेट हो जाती है. So what we do, we either standardize it or normalize it. So here we use min-max scalar. How do we do that? We use min-max scalar and we use fit transform and we display. I'll do that in a while. Give me a minute. There has been one error, so I'll upload the sheet once again to fix it, and then I'll show you the output of this. Meanwhile, firstly, I'll explain what is happening. तो min-max scalar basically हमें फीचर्स को जब भी 0 to 1 में स्केल करना है तो we use min-max scalars. After that, we use fit transform. अब fit transform क्या करता है? Fit does what? There are two things being used here, fit and then transform. Fit, suppose आप निकाल रहे हैं x minus mean upon standard deviation. Fit क्या करेगा? आपका मीन और स्टैंडर्ड डेविएशन की वैल्यू निकाल देगा. Then you would want to apply it to your data set. So fit underscore transform would apply it. And then you get the scaled results. अब scaling आपको किस पे करनी थी? It would give you in the range 0 to 1. So you get the x scaled data, and if I get the output of this, now you would be able to see that your entire range of your data would be from 0 to 1. The values would be from 0 to 1. जो बहुत ज़्यादा difference था वो हट जाएगा. After that, you apply the chi-square feature selection. And how do we do that? आपको याद हो शुरू में हमने यहाँ पर select k best जो है ये import किया था from sklearn feature selection. So I imported this class select k best from the sklearn feature selection library. So if I come here, yeah. So select k best क्या करता है? K best features. It gives me the k best features by using a particular model. अब whatever statistical method you are using. Select key best के first parameter में I give it that I am using chi2. So I'll just put here chi2, comma, k equals to 2. K is the number of features that I want to derive from my model. So I'm setting this as 2, that I want 2 best features. I can set it to 3, 4 here to perchance this is a very small data set. So it has only 4 features now, because now I increased it. As you can see, we increased it. फीचर 3 को हमने बढ़ा लिया था, और इसके हमने दो फीचर 3_1 फीचर 3_2. सो नाउ इट हैड 4 फीचर्स. तो ये बहुत छोटा सा डेटा सेट है. इसमें आप that's why I've taken k equal to 2, that I'll see what top 2 features are. Now I store the output that I get from select k best into per se any variable name. Chi_selector is the name that I've given. Then on this chi selector, I'll fit my model, fit_transform, as I told you earlier also, fit_transform, and I give my data to it. What my data is, I'll give x scaled and I'll give y. X is the features, and Y is my target. So I give this as the input. Then I get the K best features, and I per se store it in X K best. And if I run this code, it would give me the K best features. And that is how, it works. So now I'll take you to another sheet, and let me open another sheet. It also works the same way, but here I have taken up, uploaded a data set, and so on the similar lines, I have imported pandas, I've imported NumPy, I've imported sklearn from feature selection, select k-best, chi2, and I have imported this data set, which is there in sklearn. So from sklearn.datasets, I've imported load breast cancer dataset. So because that was a very small data set, so I've taken up a bigger one now in this example. And let us run it. So this is all the importing all the necessary libraries and getting the data. Now how it looks like. I've just executed it, may take a minute. Okay, they're giving me some errors, so let us try once more. Yeah, so here we have. So this is how my data looks like. I have printed the top 4 rows of this data. And you can see mean radius, mean texture, mean parameter. So these are all the features in this data. So इस data set में आपका target अलग है और features अलग है. जो आपका scikit-learn ने ये data set दिया हुआ है, पर से इसमें जो data part है वो अलग है और जो target part है वो अलग है. और इसमें X में मैंने वो data part लिया है, means I've taken all the features in X, and in Y I've taken the target. So अब अगर मैं Y देखना चाहूँ, if I want to see what is my Y here, you can see initially for first 5 it is 0. So this is basically breast cancer data set, whether it is with all these features, the output is it is malign or malignant. So initially you can see all are 0. So maybe yes, obviously very few would have. So let me say if we see first 20 outputs, all 0, 0, 0. Oh, 19th, at 19th, 20th place, it is 1. And about this data set, DF, if I For X, it has 30 columns. It has 30 columns. Now again, you use select K best. The score function that you use is chi2, and per se, I want that I need 5 features and I store it in best features. To this best features, I use fit transform method and I give my input. इनपुट क्या है, x है और y है. यहाँ पे मैंने इनपुट को स्केल नहीं किया 0 और 1 में. That we can do, but here I have not done. And then you see, you have applied the select k best. आपने कितने फीचर्स बोला था उसको निकालने के लिए? 5. And you see that it has 569 rows and it has 5 columns. So अब आपके पास 5 columns के features आ गए हैं. अब I want to see what are the names of those 5 features. I can do so by using very simple functions. Get support. Get support is the function that helps me finding out the names. So अभी हमने यहाँ पर बेस्ट फीचर्स अपने निकाले थे. बेस्ट फीचर्स डॉट गेट सपोर्ट में यूज करूंगी और उसमें मैं कॉलम्स ले लूंगी उसके सारे. So and I print them. So I get the 5 top 5 features. Now if I want to see the scores of all those features, again a very simple thing that we use, best feature scores. This gives me the scores for the best features. And if I print all the features, you can see that this 23rd feature, worst area, has got the maximum score. So this would be the one to come into my feature set. Then second is the third feature, that is mean area, and it has this score. So descending order में इनको arrange कराया है. And you can see for all the features, you get a score. And not all the features must be relevant, as you can see for many, the values is very, very less. So that is how, these are all the 5 features that I selected. So it is up to me. After this, what I can do is I can apply these 5 features to the training model and then see how my training model performs. So this is all about filter-based approach based on chi-square test. Now I would like to give you a demo of forward feature selection technique, a wrapper-based approach. And I'll be using ML extend library, that is machine learning extension. And that is very, very helpful for when we are working on machine learning models. On a similar way, I'll import my pandas library. I'll import NumPy. I'll use feature selection and import select k-best like I did earlier. Then I'll import linear regression. वहां हमने chi-square किया था तो chi2 हमने import किया था. और यहाँ पर जो machine learning model मैं use करूंगी वो मैं linear regression choose कर रही हूँ. So I'll import linear regression. और चूंकि machine learning model use कर रहे हैं, so I need to use ML extend and I use sequential feature selector. So this is very, very important. अगर हम ML extend यूज कर रहे हैं, so मैं sequential feature selector जो है, I'll import that. और बार बार इतना लंबा sequential feature extractor selector लिखना would not be a good idea. So I'll just give it a cute small name, that is SFS. So these are the initial things that you do to import all the libraries. अब यहाँ पे what I have done is I have taken अभी तक जो मैंने 2 example लिए, एक में what I have taken, I have created a small data set over there, only given it as an input. In second, I have taken some data set from sklearn library. And अगर आप वहां पे कोई गूगल का लिंक दे देंगे तो वो भी वर्क करेगा. और यहाँ पे I'll share with you how to upload a Excel or a data file from your own system. अगर मुझे अपने system से किसी फाइल को upload करना है, so how do I do that? That is from google.colab, import files, and then you write files.upload. When you click it, it would give you a prompt on from where you want to upload the file. Let us execute it and see what it does. I think I missed out on executing the first. Yeah, now it has come up. So it gives you an option, choose file. So I'll select, and I'll select, say, this 50 startups data. So there was a CSV file I had, and I have uploaded that file into it. So that is how you can upload your file. Now what I do here, rest most of the things are same. Whatever we have done, we'll prepare our data for, I'll separate the last column. I'll take the initial columns. Let me show you how this data looks like. As you can see here. So df, if I want to see the shape of this, I'll use df.shape, and let us see how many rows and columns it has. It has 50 rows and 5 columns, right? So now again, how it looked like, as you must have seen, df.head, and I see, say I want to see the first 4 columns, first 4 rows. So it is going to give me first 4 rows, and you can see that the first column is research and development, administration, marketing, में how much has been spent, in what state, and what is the profit. Now profit के basis पर last is profit. I want to select the best 2 columns and then see how it works. How it would do, you would do. Firstly, you would prepare कि ये जो लास्ट वाला कॉलम है मेरा प्रॉफिट, उसको मैं एक अलग वेरिएबल में स्टोर करूं, और ये जो बाकी 4 कॉलम्स है इनको अलग स्टोर करूं. So the same way you use df.drop and x is equal to 1, and you separate that attribute profit, the last one you separate, and then after that, if you see x, and I suppose per se, I want to see the first 4 values of x. You can see that I have now these 4. And if I want to see y, y was small, it would give me an error. I did this same thing. Okay, so last is, now in y you have profits being stored. So that is how now your x and y looks like. You prepared your data, that were your features. Now, in your x, you had this as categorical variable, state. New York, California, Florida, New York. So I would like to code it. Again, with the one hot encoding, you use get dummies, pass x to it, column is equal to state, d type is equal to int, and you display the new data frame with encoded features. As you can see, it divides that. There were 3 states, California, Florida, and New York. उसमें 3 values थी उस categorical variable में. It would create 3 columns. So first was New York, so it would have 001. The second was California, it would have 100. So that is how this is called one hot encoding, and that is absolutely necessary for many of the machine learning models. Then this is my now x. I have prepared my input x. After that, I am importing the train test split from sklearn. At times you want to use some set of data for the training, some set of data for the testing. So you separate the training and test data. And normally 80% of the data is used for training and your 20% of the data is used for testing. So that is how you have just, आपने अपने पूरे डेटा में से कुछ 80% डेटा अलग कर लिया है ट्रेनिंग कराने के लिए अभी अपने मॉडल की. जहां पर भी मशीन लर्निंग मॉडल यूज होगा वहां पे विल use train and test and validation also, though here I have not used the validation आगे भी मैंने अभी यूज नहीं किया है, but yeah, we can do that. Then from ml extend dot feature selection, import sequential feature selector. ये दोबारा से लिख दिया है, दो I have already imported it above also. ये हमने ऊपर import किया हुआ था, so there was no need to import it again. So I must have missed it. So yeah, but we need these libraries and I have imported from these libraries. I've imported this SFS sequential feature selector method. Then I call this linear regression. I call the linear regression model. And then from SFS, this you need to understand. See, this sequential feature selector, I'll pass what I'm using linear regression model. So first parameter would be what model I'm using, linear regression. Then the number of features, how many features I want per se, say 2 features. Then forward equal to true. Forward, I told you there are two things in which you can proceed: forward feature selection and backward feature selection. So if I make forward equal to true, it would do forward feature selection. If I make forward equal to false, it would do backward feature selection. See, it is so simple. Then verbose equal to 2. Verbose basically gives you how much detailing you need. अगर आपको कुछ भी डिटेल नहीं चाहिए इसको एग्जीक्यूट करते हुए बाद में, तो ये 0 लिखिए आप. Otherwise, it can take 3 values. If you want some details, you give it 1. If you want all the details, you give 2. Then scoring equals to negative mean squared error. जो आप ये सिक्वेंशियल फीचर सिलेक्टर आप अप्लाई कर रहे हैं, ऑब्वियसली किसी ना किसी परफॉर्मेंस इंडेक्स पे आप मेजर करेंगे. नाउ व्हाट इज द परफॉर्मेंस इंडेक्स दैट इट इज यूजिंग? वी आर यूजिंग नेगेटिव मीन स्क्वायर्ड एरर, क्योंकि नॉर्मली जो रिग्रेशन होता है उसमें हम परफॉर्मेंस मीन स्क्वायर एरर यूज करते हैं, और यहाँ पे हम जो मॉडल है वो क्योंकि पॉजिटिव पे वर्क करता है, तो इसीलिए यहाँ पे उसको नेगेटिव ले लिया जाता है, मीन स्क्वायर एरर को नेगेट करके ले लिया जाता है, सो दैट इन बाद में ये पॉजिटिव हो जाए. आफ्टर दैट, वंस यू हैव created this SFS sequential feature selector, given it all the parameters that you are using the regression model, you want 2 features, whatever you need, you store it in SFS1. To this SFS1, you fit transform it. Here transform you don't need, but anyhow you can write that also. But SFS1 dot fit, आप उस अपने मॉडल में उसको फिट करेंगे. क्या देना है? फिट मीन्स यू नीड टू पास द ट्रेनिंग डेटा टू इट. सो ट्रेनिंग डेटा क्या था आपका? एक्स ट्रेन, वाई ट्रेन, दैट यू पास टू दिस and you store it in SFS1 again. And let me execute all this. Basically, I missed out on executing the previous codes. So here you have just basically got your model. You are building your model. You have built your model here till this point. You have built your model using linear regression and sequential feature selector you have built. Now you will pass the training training data to your sequential feature selector. And you can see you get, since you wanted 2 features, so feature 1 out of 2, this is the score, and feature 2 out of 2, this is the score. So it is going to give me all the details. अगर मैं यहाँ पर verbose को 0 कर दूं तो ये सारे details omit हो जाएंगे. So then it will not give me any details. As you can see, now if I make this verbose as 1, it would give me some details. Yeah. Features 2, 2 out of 2. Then I want to see all the features. तो जो ये मैंने मॉडल ट्रेन किया है, I've stored it in SFS1. SFS1 में K underscore feature names gives me the feature names, and I get it printed. And you see that these are the top two features that my model returns: R&D spend and administration. And if I want to, see, this is my new data set with two features, and this is the output. And if you want to, you can, evaluate the performance also. I'll quickly, I'll quickly go through this code and we share how you can evaluate the performance of your model. So let me start again. Initially, you import all the libraries, do the, it's almost the same what we did in our previous code, pandas, sklearn. I'm using this load diabetes dataset from sklearn here. Then I'm using linear regression, train test split I need from sklearn model selection, then sequential feature selector I need, and then mean squared error I'll be using as a matrix to evaluate the performance. So if I run this, I'll show you how there are so many sessions it is saying. So let me just close one and then execute. Okay, so collab is telling me that you have opened so many sessions, so maybe I'm not able to close them as of now since I'm into an online meeting. So, but yeah, I'll show you. But I really wanted to show the output of this code. Let me log in once again. Let me close it and start with it once more. So it may take a few minutes because it's an online platform. Still now it is taking, I need to basically now I need to exit out of my Google account and then re-log in, and then it would work. But anyhow, I'll explain what I wanted to show, that I can evaluate the performance of my Google Colab. Evaluate the performance of my model based on the mean square error. So जितने भी मेरा जैसे कैसे उसने डिसाइड किया कि इस फीचर का स्कोर कितना है. सो 1 और 2 जब लिया तो क्या स्कोर आया, 2 फीचर्स लिए तो क्या आया, 3 लिए तो क्या आया. सो दैट वेज यू कैन रन अ लूप. आप एक लूप में इसको पूरा चलाएंगे, सो इट कैन गिव यू द डिटेल्स ऑफ व्हाट इज द परफॉर्मेंस एट एवरी स्टेप, एंड देन यू कैन प्लॉट इट ऑल्सो. बट एनी हाउ द क्रक्स ऑफ द स्टोरी इज दैट यू get the data, you input the data and you get the appropriate features out of it, and then whatever features you get, you feed it to your any machine learning model for working on. So either ways the feature can be selected either by using a filter approach or can be executed with the help of a wrapper approach. तो आप किसी भी approach को use करके features को extract कर सकते हैं, and you can evaluate your how the features are being extracted, what is the score, as I showed you in the earlier case कि सबका स्कोर आपके पास आ जाता है when I'm using a filter approach. In case of a wrapper approach, जो भी आप यूज कर रहे हैं, से मीन स्क्वायर एरर यूज कर रहे हैं, सो मीन स्क्वायर एरर की वैल्यू आप स्टोर करके प्लॉट करा सकते हैं बेस्ड ऑन वॉट एवर फीचर्स आर टेकन एट एवरी स्टेप. सो जितने भी फीचर्स हैं, जब मैंने ये लूप चलाया फॉर के इन रेंज 1 to मैक्सिमम फीचर्स, सो पहले 1 के लिए मीन स्क्वायर एरर कितना है वो आएगा, फिर 2 फीचर्स के लिए आएगा, 3 फीचर्स के लिए आएगा, एंड दैट वेज यू कैन, दिस इज जस्ट फॉर अ विजुअल प्लॉटिंग ऑफ how it looks like to increase the number of features, and it would tell you is I can share this code with all of you. It can give you a picturesque description wherein कि सभी फीचर्स ले ले तो परफॉर्मेंस अच्छी नहीं आती. But if you reduce the features and take the relevant ones, the mean square error is actually lesser. So the performance is better. So that is how your RIPER approach works. And with this, I finish up with the hands-on session also. Now I can take up any questions that you have. So let me stop sharing my screen and I can take up any questions that you have from this session. I hope you have got a gist of what feature selection techniques is. In case of computer science, you need to, do the hands-on and practice. Until you practice it on your own, you won't be able to gain confidence out of it. But yeah, I hope I have been able to give you a basic understanding of feature selection and how how it is used in case of how you can use Google Colab, how you can get the data, how you can extract the features using filter-based approaches and using wrapper-based approaches. So yeah, over to audience. Any doubts? 10 minutes left. So whatever doubts you can have, we can have it for discussion session. Yes. Okay, so any questions? Yes, to all the audience. If you have any questions, you can please ask the organizers can unmute and yeah. So
Dear
basically to
participants, if,
understand, yeah. Yeah,
dear
got it.
participants, if you have any question, you can write down in the chat box. Ma'am, one question is there. Dr. Chirag is asking, can we accumulate fuzzy set theory with this method?
Fuzzy set theory, I have not done so. So I'm not sure that whether we can, because machine learning models, I have worked on machine learning models. So I can confidently tell you about machine learning, but I've not applied fuzzy learning models to the feature selection techniques. So I cannot comment on that as of now. Okay, one has written that how does it differ from factor analysis? Okay, factor analysis is basically when you focus more on the type of data and you are finding out what are the factors in the data. Here it is basically working on the overall framework on what is going to give you the better. You're not focusing on much on what type of data it is. यहाँ मैंने कभी नहीं ज्यादा फोकस किया कि डेटा कैसा होगा. वहां पर focus is on the data type. What are the factors that are there in the data? Here it is basically how your model would perform with a particular set of features.
Any other questions, participants?
So I hope you would be able to take it up, apply it to various machine learning approaches. तो जब भी आप मशीन लर्निंग में वर्क करेंगे सो इट वुड नॉट बी द केस कि आपको फीचर सिलेक्शन अप्लाई ना करना पड़े, बट या आप डीप लर्निंग में वर्क करेंगे तो डीप लर्निंग मॉडल्स में आपको फीचर सिलेक्शन एक्सप्लिसिटली अप्लाई करने की जरूरत नहीं होती. In that case the model implicitly एक्सट्रैक्ट्स दी फीचर्स. जैसे अगर हम कन्वोल्यूशन न्यूरल नेटवर्क्स की बात करें तो वो अपने आप फीचर्स को क्या करता है, एक्सट्रैक्ट करता है. वहां पर आपको मैनुअल फीचर्स को इनपुट करने की जरूरत नहीं होती. जैसे आप सिंपल इमेज देंगे और वो अपने आप से आपको बता देगा व्हाट टाइप ऑफ इमेज इट इज, ऑब्जेक्ट डिटेक्शन करना है तो सो ऑल दैट टाइप ऑफ स्टफ. इन दैट केस यू डोंट नीड टू गिव द एक्सप्लिसिट फीचर्स. But here, if you are using any machine learning model, you need to give the explicit set of features. So, but yeah, the problem sets are different for certain, when the data is not large, you cannot apply deep learning models. Then you need to apply the machine learning models only. And in that case, feature selection is gets very, very relevant. So thank you all. And thank you, organizers.
Thank you, ma'am, for the wonderful session. Thank you so much. Now we have our next session. The next session is on bootstrapping of interest rates in financial modeling. We have with us Ms. Aastha Malhotra. She is an assistant manager in KPMG, Gurugram. She's a skilled risk professional in the financial risk domain. She's certified financial risk manager from GA and gold medalist in executive general management program from MDI Gurugram. She has done her MA economics from JNU and she has also cleared UGC NET in economics. She possesses practical knowledge in financial modeling. Now I would request Aastha Malhotra to take the session. You can unmute yourself, Aastha.
Hey, uh, good evening, everybody. My name is Aastha, as Gaurav has already introduced me. Today, I'll be talking about bootstrapping of the interest rates, right? That is widely used in market risk, finance domain, right? And none of us, I believe, is very far away from market and stocks. So basically, these concepts, once understood very deeply, come very handy in terms of understanding market, in terms of making financial decisions, right? Uh, uh, Right. We'll be starting with bootstrapping of the interest rates. Before that, before we go on deep into mathematics of it, understanding all of it, I would like to basically, clear some basic concepts first, and then we'll gradually move into the bootstrapping of interest rates. The name sounds really heavy, but technically it's not very heavy. I'll try my best to give you a gist of bootstrapping of interest rates in layman language. Okay, so let me present my screen. Gaurav, please give me a heads up when once you guys are able to see my screen.
Yeah, sure. Yes,
Is
the
my
screen is visible.
the screen is visible? Right.
Yes.
Okay, great. So, just giving you a summary of what we're going to discuss today. Firstly, we'll talk about present value. Then we talk present value of money in general. Then we talk about various types of interest rates that we hear in the market. Then we talk about various types of curves and their types, basically yield curves, and what are the types that we see. Gradually, we'll come on bootstrapping. Example, we'll also see Excel implementation of bootstrapping, right? And then some applications of bootstrapping along with how we use bootstrapping of the SOFO curve. Gradually, when we talk about each topic, I'm going to explain in greater detail what bootstrapping is. Okay. First thing is discount factor and rates. What is a discount factor? Right. So something 100 rupees is worth more today than tomorrow, and it is worth more tomorrow than day after tomorrow. So the point is the value of money, same amount of money decreases in future. Now you might think, why does that happen? You can give credits to inflation. You can give credits to the fact that you could have earned the, if you had wouldn't have got the money, if you have the money today, you can also earn some interest on it, right? So the idea of discounting itself is a dollar or a rupee is worth more today than in future. That is simple value of simple concept of present value. So the what the discount factor does, it scales down future cash flows based on time value of money. Time value of money, anything that I have today, whatever I have today in hand, is worth more than the same amount in future. Remember? Now, as time increases, right? So if I'm going to get, say, $100 this year, right? Compared to $100 in 2026 or compared to $100 in 27. So the value of $100 in 2025 is more than the value of $100 in 2026, and the value of $100 in 2026 is more than the value of $100 in 2027, right? Because as n increases, or even as discounting increases, as I give more and more weightage to the present value that I have in hand, the discount factor increases, right? This is how we calculate the discount factor. I'm going to give you the maths of it, like what are the general rates at what we discount. We usually discount at risk-free rate. You might want to take notes of it. So basically we would not discount at the rates that you might get on mutual funds or you might get on risky investments. The rate that we use for discounting, basically कि मुझे उसको कितना scale down करना है, I am going to use a nominal rate which I can earn on a simple investment, right? On a government based investment, that is usually known as risk free rate in the market, right? So as the time increases, right, I'm going to discount more. If $100 in 2026 is more than $100 in 2030. So therefore, discount factor of 2030 is going to be greater than the discount factor in 2026, because I am going to, the nearest future will be discounted with a lesser number, and the discount factor in future is going to be discounted with a greater factor. Basically, the amount jitna aap kam kar rahe ho, because you getting it late in future, right? This is simple discounting. And as so risk free rate also doesn't stay constant in the market. You will see every day, you will get notifications on Economic Times, on Times of India. If you read newspapers, okay, government has increased the rates by 25 bips. The normal terminology that you use, it's bips. So 1% is equals to 100 bips. So whenever you see 25 bips, 50 bips, that simply means 0.25%, 0.5% bips. When I say bips, it is BPS, everything written in smaller case. So that is the amount that you're going to basically see. So the discounting rate itself keeps changing as the government changes the rates. The risk-free rates are changed. That's how the discounting also changed. So discount factor, as we understand, कि मुझे आज जो amount मिल रहा है, right? So how am I going to discount it will depend on two things. Basically, on the number of years. If I'm going to get something at a later period, as number of years increases, discount factor will increase, and as the rate which is set by the government, that I'm terming it as a risk-free rate, as the risk-free rate increases, then also I'm going to discount something more. If government is, for example, giving 4% in this year, but government decides to give 6% in next year, right? So basic idea of risk-free rate changes for me, right? So I'm usually you will not see 2% variation. You will see variations that happen gradually. Every quarter, the rates change. Every semi-annually, the rates change. The rates that all of us get on a, provident funds, the rates that we get on our normal FDs, they are similar, right? Reverse repo rates. So those rates are usually risk-free rates. No, not the rate of return that you would get on a XYZ property, or the not the rate of return that you will get in mutual funds. So no, not those rates. Those are not risk free. I'm sure you would have read those lines. Mutual funds, this is market investment and market risk is involved. This is a basic line that is involved in mutual funds also, right? So we're not talking about risky rates, risk-free rates, the government basic rates in the economy that you would earn if you were to invest in a normal scenario. FD, PFs, those rates are risk-free rates. Now, interest rates used to discount future cash flows to their present values are usually the risk rates that I have already spoken about. Now, relation to spot rates. So, what are these discount rates called in general? The normal rate, the risk-free rate that I'm talking about. In general, what is it called? It is called nothing but the spot rate. So, whenever you hear the term spot rate, that is usually the risk-free rate that is used for discounting. So, whenever I'm going to talk about discounting in future, I want spot rates. And that's the whole purpose of having this session, that we are going to calculate those spot rates. Now you would say, how are we going to calculate these spot rates, right? In Indian economy, you might say, okay, government traded instruments. So now government, it's easy to say the government has increased the rates. When and right now also to explain you in layman language, I gave an idea of risk-free rates to explain you FD rates, PF rates, those rates, right? But I spoke about a lot of instruments, if you noticed. So the actual spot rates that we're going to use are derived from par rates, which we're going to discuss in the session further. But spot rates, please remember, spot rates are the rates that are used for discounting cash flows. Cash flow is anything that you are bound to receive from a particular instrument, from a particular investment. Whatever cash flow that you get from an investment, it's nothing but the amount that you get from an investment is cash flow, right? So moving on, discount factor and rates. I hope this is clear. As number of time, I'm going to revise every few minutes we talk about a slide. As number of years increase, the discount factor would increase, right? And as the rate itself increases, right? As the rate itself increases, then also the discount factor is going to increase. Moving on, present value, as I've already spoken about, it's a financial concept that represents the current worth of a future sum of money. If you're about to get, so for example, to make it relatable to all of us present on this meeting today. So for example, you are about to receive, say we have 20 years of employment left, right? And we expect a sum of 80 lakhs, or maybe just say 1 crore in future, right? If we are expecting 1 crore in future, then how much is that 1 crore in future worth today? It might seem, oh, we're going to get 1 crore. It helps us to plan our investment saving, to have investment. So basically, we can smoothen our consumption. Why it is important to learn the concept of present value and discounting, so that we don't overspend today, and in later we are not left with enough surplus or corpus to lead our lives. We're going to work for a certain number of years. So for example, we are bound to receive 1 crore when we retire. So let's see how much 1 crore is worth today. If I discount 1 crore, right, by say let's say 6%, right, 30 years later, so what will be the amount? Can people write in the chat box if they can simply use discounting? Let me see if I have replies. Or maybe let me just let you know the formula. I think it's up on the screen, but still let me explain it. Let's go slowly. First is it helps to determine the how much future amount is worth today. So for example, future, if you are expected, let me talk about an example first, maybe then I'll give you questions and then I'll expect answers also. Now, for example, you are expected to receive $1,000 after 3 years, right? And the discount rate that I'm talking about today is 5%. Then the present value of $1,000 today is 864. It's after 3 years. Imagine what this $1,000 would be if I would have done 30 years. This would be nothing today. Similarly, you can also use this concept to get the amount. See, we have two things. We have FV is nothing but the future value. PV is nothing but the present value. So if I'm saying that you are bound to receive 1 crore in future, that means FV, anything that you receive in future is the future value, and anything that you receive today is the present value. Now basically the idea that we're discussing right now, we want to calculate present value. So how do we calculate present value? We simply put instead of future value, put 1 crore. In the denominator, what will we put? In the denominator, we're going to have 1 plus say 5%, if we consider 5% discounting also. So R would be nothing but 0.05. 5% is nothing but 0.05. To the power, now what is the number of years now? 30. Because we are expecting to work 30 more years till we retire, or 20, 25, based on your individual number of years that are left. You can put the number and see how much your PF is worth today, right? And similarly, if you are investing in an instrument, I'm sure all of us get in calls from insurance agents. We get, multiple calls from our bank relationship managers, telling us, okay, if you invest itna, then you're going to get itna after 20 years. So how do you know whether you want to make that decision or not? You have this formula handy in your hand. What do? You know the present value in that case, right? So if present value in my case is my present value. So for example, if someone is saying after 5 years, if you invest 1 lakh today, after 5 years, I'm going to give you say 1.7 lakhs. So whether that investment is worthy or not, how do I do at 5%? Well, how will I see? I will see 1 lakh multiplied by 1.05 into 5 times, because number of years, n is to the power. So 1.05 into 1.05 into 1.05 into 1.05 into 1.05, right? The whole amount is multiplied by 1 lakh rupees. The amount that I get is 1,27,000. So this is the basic amount that I would receive. So if someone is offering me 1,70,000, I will be like, okay, I'm sold. I will invest in that particular asset or not. You can obviously see what are the alternative investment opportunities, what is the rate that you're getting. But this is the basic formula to evaluate your investments that you're going to do. If you have the present value, if you're if you have present value, then you can calculate the future value, right? And if you have future value, you can calculate the present value today, either of it. Present value is something that you have today at time zero. Time zero, the present is considered at time zero. Future value is anything that you consider in future after n number of years, right? If n is 1, the future value is the value that you get after 1 year. If n is 30, then future value is nothing but the value that you get after 30 years, right? This is the basic formula. Now, if we are expected, as we already discussed, if we expect to receive 1,000 after 3 years, the value of 1,000 to at after 3 years is nothing but just 864 rupees right now, $864 right now. So this is the concept of present value. I hope this concept is clear. Moving on. Discount rate is nothing but the spot rate. Again, repeating, spot rate is nothing but the discount rate. So let's talk about spot rate now. Spot rates are those interest rates for a single cash flow received at a specific time. Basically, it's going to give me the return on the investment that I'm going to go with no intermediate cash flows. Now you would think, why have I written no intermediate cash flows, right? So I'm sure you're aware of the concept of insurances, if not bonds. So you usually have two types of, there are multiple types of bond, but I'm going to talk about two types in general for common man. One type of bond would be where you just invest something today, right? And then you get a final payment at the maturity, right? There is no intermediate coupon. So for example, if an agent comes to me and says, okay, madam, please invest 50,000 rupees, I am going to give you 2 lakhs after XYZ years, after say 10 years or something, right? So I invest today and then I get in for 2 lakhs, the price of that particular thing is 50,000 today, right? So this is nothing but zero coupon bond where there is no intermediate payments. But I'm 100% sure, I'm 100% confident that you guys have invested in insurance products or, market products where you get okay, monthly payments also, but not monthly, annual payments. If not monthly, annual payments. You invest, ma'am, please keep giving this much amount, and every year you'll get 2%, 5%, 7% amount of it, right? And in the end, you get the full maturity amount plus the interest, the coupon payment also. So that's nothing but a coupon paying bond. So there are two bonds: zero coupon and coupon paying bond. So uh, so in case where there is a zero coupon bond, that means there is no intermediate cash flow in between, right? So that return is comparable for counting discount rates. right, for calculating discount rates. We are not talking about the bonds which pay you annually, because that scenario is a totally different scenario. If I'm giving you coupon payments every year, if I'm giving you something today, then 5% of something today, 5% of something tomorrow, then that means I'm going to charge you also accordingly. So that rate is not that I'm accounting for right now. That I just told you about bonds. There are two types of bonds: zero coupon bond, which you invest today and you get finally at the end of n years, and there is a coupon paying bond where wherein you get amount at specific years, at in the first year, in the second year, in the third year, in the fourth year. Those are coupon paying bonds. So spot rate is only for the zero coupon bond. The yield, the return on investment that you make on a zero coupon bond, that is nothing but the spot rate, which is the discount factor that we're going to use for discounting also. Spot rates are, that's, as I said, they're very critical for discounting future cash flows to their present values. Let's talk about it with an example. I think it'll be better, it'll be more clear to you. If I have a 1 year zero coupon bond, it is priced at 950. This is the price. That means it has a face value of 1000. Face value is nothing but the future value. When the instrument is going to mature, $1,000 is something that you're going to get. So how do I know whether this instrument is, priced fairly, right? So I'm going to calculate the yield. So for example, I come to you and I say, okay, give me 950 rupees, $950 or rupees, whatever. And at the end of 1 year, I'm going to give you 1000. So whether this investment is worthy for my, worthy, or should I put $950 instead of taking a bond from me, you can put $950 in FD also. How would you know? So if a 950 is the present value that you're going to give today, 1000 is the future value that I'm promising you after 1 year, right? Because n is 1, that's why I've not written 1 plus r. If we try to solve for r, we're going to get r as 5.26%, right? And on an FD, if you are getting 4% return only, right, or in a savings bank, if you were to keep in savings bank, then you would prefer to give me 950 rupees today, because I'm going to give you better return on the investment. I am going to give you 5.26%. But if you are getting more return somewhere else in an alternative investment scheme, then what would you do? Then you would say, no, no, I am going to, because I'm not, your return on investment, madam, is 5.26%. Whereas I would want to give, if I am getting 7%, 8% in this alternative investment. So, ma'am, sorry, I cannot buy your scheme. That's how you calculate your investment. So, I hope this concept is clear. 950 is anything that you pay today is present value. Anything you get to later is face value, future value of the bond. So this is how the spot rate is calculated. So now, very interesting concept of bootstrapping comes. This is nothing that we just bootstrap the spot rate from a traded instrument. Now you would say, why do we even need to bootstrap, right? So the rates in the market, right, are not very clearly visible. There is no such thing as perfect information. Everything, there is no such thing as white or black. Everything that you see in the market is gray. Everything. There is no perfect information. There is no information symmetry, that okay, if I know something, the person in front of me, the other party, also knows that much only. There is always information asymmetry. There is always a gray area in between, right? That is why the concept of bootstrapping comes in. What is bootstrapping? What we did just now, to see, on the face of it, if you guys had not attended this class, what you would say, okay, 950, without even making a sound decision, you would have simply said, okay, take 950, give me 1000. Oh, I'm going to get more than what I'm investing. But a sound investor, what the sound investor would do, that sound investor would calculate the return. Now, as I said, anything is not white or black. There is no perfect information. There is information asymmetry. So I would say bootstrapping is nothing but a tool to break that asymmetry in information, right? To, instead of making gray, I would want to basically make some things white or black for me, right? To make the decision, I need the dust to settle and to see the things very clearly. What we did right now is we bootstrap the rate by the prices that we have. We bootstrapped, okay, if this is this, then rate is going to be this, right? From the zero coupon bond. Now you would say, where else do we see bootstrapping? I would like to talk a little bit more on bootstrapping, since the topic itself is bootstrapping. Now in bootstrapping, what happens? So for example, you want to buy a property in XYZ area, right? The builder is not our relative, not our friend, is not going to give us the best rate, right? So what will you do? How do you know that the price the builder is charging you is correct or not? How do you evaluate that? You would inquire in the neighboring area. Okay, this property was sold for how much? Okay, the per square feet cost or per square yard cost is 10,000 rupees or 5,000 rupees. Okay, that, and if your buyer is, if your builder is quoting you something totally away from 10,000 rupees, if they're quoting you 15,000, then you will question that person. Oh, I compared, basically I compared, this property was sold at this much per square feet, right? So you will see how much area was sold, what was the total cost, and from that total cost you will calculate the per square feet cost. Obviously there will not be an apples to apples comparison, because the unit that your builder might be selling might not be the same as the other builder would have sold, right? Other builder could have sold a 2,000 square feet flat, and your builder might be giving you 1,000 or 1,500 square feet flat. So what will you do? You will see, okay, if the total cost is this much of the flat, the total area is this much, so you will calculate. So you will bootstrap the per square feet cost, and then using that per square feet cost, you will multiply it with your area and see, okay, whether the amount that the builder is charging is correct or not. So to break the information asymmetry, you will bootstrap this. Bootstrapping is something, the things that are already traded in the market, from traded instruments, from traded financial instruments. What you do is you take that information, whatever is there, and calculate the thing that is important to you. In this case, interest rate is more valuable to me, because I was considering an alternative investment that would have probably given me 10%, 12%, 15%, right? We all make these decisions. Money is of utmost importance to everyone. Everyone, I'm sure good health is also there. Don't want to go too philosophical there. I hope you guys are laughing too. Right, money is very important to all of us. So having these tools handy with us, for everyone, no matter which background you come from, it becomes so easy to calculate whether we want to make an investment or not. Very sound educated people go wrong when they make investments, right? They don't read the documents fully. They, the some by word of mouth, okay, you've also invested in this, okay, fine, I'll also invest in this. But sometimes those things go wrong, and this, sometimes it's a very soft way of saying, sometimes happen more than a lot of times. It's a soft way of saying sometimes. So by doing these, by knowing all of this, you can make sound decisions. You do a thorough comparison, you do a thorough analysis of things around you. You see how the market is actually performing. You bootstrap from the information that is already given in the market. You take the thing that is of your interest in this case, and then you see, okay, if you are suppose uh, in this case you're calculating discount rates, in other case you're getting the per square feet cost. I hope this concept of spot rate is clear. So I know the price, that is PV. I know the future value, that is 1,000, and then I calculate the return on investment. If an alternative investment scheme could be as simple as FD. Okay, if I'm getting 7% FD, why do I need to take this instrument? No, okay, bye, I don't need it, right? You'll be able to make sound choices in that case. After spot rates, we're going to discuss par rates. Now, par rates are the coupon rates on bonds that make the bonds price equal to the face value. Face value, that means the price that I'm going to give today is equal to the face value. In other words, if the it's the yield on a bond that sells at par. If I'm going to get 1,000 rupees face value, then at what rate uh, is my price, market price, going to be equal to that. So par rate, that's in the case of a bond. We also have an instrument known as interest rate swap. Interest rate swap, usually banks do that a lot. In For common man also, sometimes people to hedge their uh, risk, basically. So whenever we take loans, so for example, we might take home loans, we might take automobile loans, we might take consumption loans, right? To hedge our interest rate risk. So for example, what is an interest rate risk? So currently the market rate is say 8% on home loan, right? Now I'm worrying, if the economic activity is in the market is at boom, I might worry that the government is going to increase the rate further. what will I do? I will probably enter into an interest rate swap wherein I will say, no, I will pay you based on fixed rate only, but you pay me on the basis of floating rate, whatever the rate would be. Now, floating rate could be any rate in the market. It could be it basically it will be indexed to a particular curve. We have different curves in the market. We have SOFR curve, we have LIBOR curves, we have Fed rate curves. Multiple curves are there. So basically, if whatever the price, so for simple layman in layman's language, I can say that in layman language, I can say it is tagged to a particular secured funding rate curve. So maybe say repo rate, whatever the rate of the government will be, the rate at which the government is going to give loans to the banks, that is repo rate, right? So maybe you can say the floating rate, whatever the rate will be at that time, you're going to get that. So that is an interest rate swap, wherein one party pays fixed interest rate and other party pays floating interest rate. Floating interest rate is nothing but as per the market conditions at that time. So in that case, you might think, okay, this is going to, the other party is going to be in loss. That's really not the case. It is very much possible in market. You don't know whether the market is going to crash tomorrow or not. No one can predict market. There is no quantitative maths. There is no quantitative finance which can predict, okay, this is going to increase or this is going to fall. Everyone will make estimates. They will make predictions. They will make estimations. No one is going to say for certain. Bring me one person who says by certain, okay, market is going to fall by this many points or increase that this many points. There are so many behavioral, psychological points. That is why these instruments, these rates that we see are up on the screen. Otherwise, we wouldn't be discussing them at all if everything was as crystal clear as we think it is. There are so many factors, then we can probably imagine model in terms of market risk, right? So let's talk about interest rate. Let's not digress more. Interest rate swap is an instrument wherein one party will pay fixed, another party will pay floating rate. Who will determine whether the fixed rate party is going to benefit or the uh, floating rate party is going to determine? Who determines that? Market. Future will tell. But when the swap is traded at the initiation, the none of the parties benefiting. The rate is set as such that none of the party benefits. The value of the swap at today is only zero. That's the whole purpose of entering into a swap. I wouldn't enter into a swap if I would think that, okay, this party is going to, if either of the party knew that, okay, this party is going to benefit or this party is going to benefit, none of them would enter, right? If this was so common. So the par rate of a swap is that rate at which the value of the swap is zero at present, right? So for example, after 1 year, so currently I entered into a fixed rate swap. I am saying that I am going to give you 8%. And if the government rate is, whatever the government rate is, you have to give me that. I am thinking, okay, the rate is going to increase, so that's why I'm going to benefit, right? I'm going to think that, okay, it's going to increase more than 8%. It's going to be somewhere around 9%. I'm thinking I'll make benefit of 1% after 1 year. But what if the government rates falls to 7% next year? Then what happens? 1%. I was paying 8%. The other party of the floating rate is going to pay me 7%. So I'm at 1% loss in that case. But today, the rate 8% is decided so that the overall value of the interest rate swap, that means the value of interest rate swap at initiation, is nothing but zero. That rate is nothing but the par rate. For a bond, where bond is a different instrument where you can have coupon and one final payment in the end, multiple coupons every year and one final payment, that is a coupon paying bond. You can also have a zero coupon bond where you pay something in the beginning, the price of the bond, and you get anything in the end. That is zero coupon bond. So that is a bond where you pay the price, you get a future value. But in interest rate swap, there are multiple payments after every year. Interest rate swap could be for 1 year, 2 year, it could be semi-annual also, right? In semi-annual means after every 6 months, we exchange the rates that are there in the market. Basically, one party pays the fixed rate, another party pays the floating rate, whatever the government's rate is at that in that quarter, right? That is, but for par rate is a fair value concept where I'm saying there is no profit to one party. Neither the fixed party is making profit nor the floating party is making profit in the beginning, at the initiation only, right? And when the deal is set, that's when the par rate comes into picture. So these par rates are used to construct yield curve, specifically the par yield curve, which is usually available in the market. Because par yield curves are available in the market. That's why I need to bootstrap the information of spot rate, right? Because par rates are fair rates. Anything that I need to discount should be fair. It cannot be very risky, right? And it cannot benefit one party. The information, as much fair information I get from the market, that is easy for me to make more decisions easily. So par rates are used to construct yield curves, specifically the par yield curve. Now, for example, if I'm saying a bond with a face value of 1000 and the coupon rate of 5% trades at par. The I'm saying the coupon rate of 5% trades at par, that means the par rate is nothing but 5%. So in case where coupon rate is less than the par rate, that means the bond is sold at a discount. It is sold lesser value than lesser price than the future value. And in case where par rate is the fair rate, if I'm going to give you coupon every year more than the par rate, if the par rate in the economy is 5%, but I'm going to give you coupon like 7% of say 1000, that means how much? $70 every year and then 1000 in the end also. If I am giving you more, then obviously I'm going to charge you more. There are no freebies in the market, right? No one is a relative, no one is a friend, no one is going to give freebies in the market. They're going to charge a premium for, if they're giving something more, they're going to charge a premium for that, right? So anything that is, so if coupon rate is less than the fair rate, that means the bond is sold at a discount. If coupon rate is greater than the par rate, that means it is sold at premium in terms of bond. There is an example here. Suppose the bond has a face value of 1000, right? That means in future it's going to be sold at the future value that I'm going to get after n number of years is 1000. But today I'm selling it for 1050 rupees. Then that means the premium is 50. Why am I doing that? PV, why is the present value greater than the future value in this case? It is greater because investor is willing to pay for a higher coupon. That means they're going to get more coupons payment in 1 2 years, whenever the whatever will be the duration of the bond. Only in that case I'm going to pay more, because I'm going to get subsequent payments also every year. That is the only case where I will pay more in the present to get finite sum in future and some discrete sums in um, the subsequent years. I hope the concept of par rate is clear. Par rate in terms of bond is different, in terms of swap is different. Now you might want to say, why are we even reading about it? So market is not as easy as it seems to be, right? Things are not directly available. You have to uh, get some information from the existing information. You have to make analysis. That's what the whole analysis comes. You have some information and then you filter the best content out of it. Filtered information, that's the best product, the concentrate of the information that you have. That's why you need to do bootstrapping. We've discussed par rates here. Now we're going to talk about swap rates. So fixed exchange rate in a swap contract for a floating rate. So whatever rate that is decided, uh, right, of a swap is the swap rate. That means the rate that fixed party pays, right? There are two parties to to basically an interest rate swap. This is vanilla interest rate swaps. You have multiple swaps available in the market. We're not talking about those exotic products. There are variance swaps. You can read about it if you're taking notes. There are inflation swaps. There are cross currency swaps. I'm not going into detail. I'm just going to talk about the basic vanilla interest rate swap, wherein one party pays fixed interest rate, another party pays floating, and they exchange the cash flows. Simple. So the rate that fixed party pays is obviously decided in the beginning. That is nothing but the swap rate. The rate that fixed party pays. For floating interest rate, you cannot decide now, because it's going to be indexed to some curve, some rate that the government announces in future only. So the name itself is floating. That means it's not going to remain constant, right? Floating is something that varies over time. I hope this information is clear. So, LIBOR is London Intermarket Borrowing Offer Rate. SOFR is secured offer Fed rate, right? You can check these rates. They are used in pricing of the uh, interest rate swaps, in discounting. You will see that these interest rates are readily available in the market. Right. LIBOR and SOFR, secured overnight financing rate. Now we're going to talk about forward rates. Right. Just a second. I also need to see where is the Excel that I wanted to show to you guys. Forward rates. Okay, let me talk about it as soon as I finish this slide. Now we talk about forward rates. These rates are agreed upon today for loans or investment that will occur in the future. Right. They are derived from spot rates only. A forward rate for a borrowing 1 year from now, for a term of 1 year, is a forward rate. Anything that the investment or something that is going to happen in future, but I'm deciding it now, that is forward rate. So when you say when you read this term FRA is nothing but forward rate agreements. These are forward rate agreements. That means this agreement starts 3 months from now and it is going to last for 9 months from now, right? That means the overall duration, active duration of this is 6 months only. 9 minus 3 is 6 months. So that means if I'm sitting in January right now, this 3 forward rate agreement is going to start in 3 months from now would be April, right? And it's going to go for another 9 months. That is till December. The active duration of this forward rate agreement would be nothing but 6 months. I'm going to show you an Excel and I'm going to tell you why it is important to read these also. Now here also, see, forward rate agreement. This starts after 6 months and it ends till the 12th month. It is not 12 months, it is 12th month. That means it's going to start in June, but it's going to end in 12th month from now only. That is December, not the next year June. Please be very careful while reading this. Forward rate agreement in the 18th month from now, that is June 2026. Going to last till the 24 months from now, not after 18. Not after 18. This is it. Everything is from now. So this is going to last till December 2026. This is forward rate. Okay. Just a second. I'm going to bring up an Excel. Gaurav, could you please confirm if the Excel is visible to you guys?
Yeah, Excel is visible.
Great. Thank you. So the yield curves that are available in the market, the screen that you see right now on my screen is nothing but these are Bloomberg screenshots, right? That I had fetched. So a curve, so you see a curve here, right? This curve in the market, it is not built from one instrument, right? Similarly, so when I said that if you're going to buy a flat, if you're going to buy something, you're not going to calculate the price of one builder only. You will go to all the neighboring builders, neighboring areas, right? You will have multiple data points to build one curve or, come to one conclusion. Similarly, in the market, we want to be as fair as possible. Our intent, our job is to have the best rate possible, the most fair rate possible, right? So the curve that is built or the curve that is bootstrapped, we have multiple instruments available in the market. So the ones, you see some values are grayed, some values are not grayed, they are highlighted, right? So the highlighted values are the values which are considered, which are the most liquid, whatever is traded more. So who decides what is fair, what is not, right? Whatever is traded the most is fair. You will also not go to a builder when you're buying a property. You will not go to someone whose properties are not sold only at all. No one goes to that. The builder has flopped. You wouldn't go to that. You would go to the most liquid ones, which is fast selling, fast moving. From the basis of those, you're going to get the prices, right? You're going to consider what is liquid, what is more traded. So the instruments which are traded the most, that's why we need to read forward rate agreements also. Otherwise, there was no need of understanding forward rate agreements at all. We would understand forward rate agreements only because they are traded the most. That's why for for very short run, we need cash rates. For medium run, we need forward rate agreements. They are the most fair rates. And for long run, right, from 18 months above, we probably come to swap rates. That's why it is important to study all the rates, right? So, for example, if you were buying properties, you would consider some low income houses, some medium, and some luxury. You will not consider, when comparing the price of a normal project, you will not take the prices of luxury project into consideration. You will see all the values, right? Maybe you will give less weightage to luxury, more to affordable. Similarly, in market, we have multiple instruments, and based on those multiple instruments, we're going to derive basically bootstrap the values of fair rates, which are nothing but the zero rate or the spot rates today, used for discounting purposes only. That's the whole purpose of getting it right. So you see on the left side, these are the cash rates. In between, when we see here, so 1 month starting after 1 month, that means it starts for in Feb and it lasts for another 7 months, that is till July. The overall duration of this forward rate agreement is nothing but 6 months. Here it starts after 2 months, that in March, but it ends till August, the 8th month of the year. That means it also, every product, that every forward rate agreement that you see over here, it lasts for 6 months. And this is the bid and ask. Usually an average of these rates is considered, and then the information is bootstrapped from these rates. Bootstrapping we will learn. There is no need to hurry. We're going to come at bootstrapping. The Excel file that I've prepared for you guys, I can send it over after the session is done for your purpose. But I want to basically make you understand why are we bootstrapping at all, right? We have tools like Bloomberg, which are not very easily available. The licenses cost is 30 to 40 to 50 lakhs, right? Although the bootstrap rates are also available in these places, right? They calculate, they do the maths, but not everyone has access to these instruments. That is why we need to basically learn how to bootstrap the rates from publicly traded instruments that are there, right? So we've discussed about this. Let's talk. You know now why we're reading forward rates. So for medium run, forward rate agreements are the most liquid traded instruments from where the spot rates are going to be bootstrapped, right? For every currency, the this proportion of how much cash rate, how much forward rate, how much swap rate is considered is different. But a combination of all these three are going to give you the yield curve. And what is yield curve? We're going to come to it very soon, just after a few slides. So just bear with me till then. There is another concept, yield to maturity. Because we were discussing all these rates, I didn't want to miss out here yield to maturity. This is nothing but the internal rate or rate of return on a bond, assuming it is held till maturity and all the payments are made as scheduled. It represents the bond's overall rate of return. It is the discount rate that equates all the future bond payments, coupon in part to the bond's market price. So yield to maturity will be more clear when we discuss this in an example. Yeah. So for example, the future value, the amount that we're going to get after 4 years, because time is 4 years in the example that I've considered, is $500. I'm going to get $500 after 4 years. The coupon rate that I'm considering is nothing but 10% here, right? The coupon is 10% that I get every, remember we talked about two bonds, zero coupon bond and coupon paying bond. If it was a zero coupon bond, then I would get nothing in between. Right after 4 years, I'm going to get $500. But now the bond is coupon paying. That means I'm going to get 10% of 500, whatever my future value is, right? Every year. 10% of 500 is simple. $50 every year. That means to $50 in year one, $50 in year two, $50 in year three, and $50 in year four. But in year four, I also get the future value, that is 500 rupees, right? So in year four, I am going to get total of 550 rupees. Now, for example, the spot rates are also given to you. Please remember, we are calculating yield to maturity here. So spot rates, for example, are available to us, right? How do we calculate the market price? We discount every payment. We calculate market price is nothing but the fair value of every cash flow. What is the cash flow? I'm getting 50 year this year, 50 dollars this year, $50 next year, 50 next to next, and remaining $550 in the end. 500 is the future value that I'm getting, and $50 is the coupon payment that I'm also eligible to get, right? So first year rate, spot rate is 10%. I will discount the first year value by 10%. And the number of year is 1, so I put 1 in the exponential power. In the second year, I'm getting $50, but the spot rate has changed 12%. That because as time increases, we expect the discounting also to increase. We had discussed in the beginning only, right? So the amount I'm going to discount it with a greater value. Time has also increased and discount factor has also increased. In a normal scenario, we have different scenarios also. Then $50 net. I'm calculating the present value of $50 that I'm going to get in the third year. 1 plus R to the power 3, because in third year, the exponential n is going to be 3. Finally, in the fourth year, I'm getting $50 of the coupon payment and 500 as the face value. So 550 discounted by 1 plus R, that is 16% for the fourth year, to the power 4. By discounting all of this, we get the price equal to 442.82. That is the fair price. If everyone knows this, if these concepts, this is also how market instruments are priced. We discount all of them and we add the cash flows. That's how fair price is calculated, right? So this is the price of this bond, which pays 10% coupon payment every year. And in the end, it gives me a face value or future value of $500. 442 is the price that you're going to pay today, right? Now, how do I get yield to maturity? What is the yield, right, that I'm getting? If I'm paying $442.82 today, what is my yield? Basically, what is the return on investment that I'm getting? Simple. What is the return on investment? It is, again, repeating, it is that internal rate of return on a bond. If it is held to maturity, all payments are made. That represents the overall return and it equates the PV of the bond and the future value. So I know the future value already. It is 442 I'm paying. So everything, R is not my concern now. I am concerned about my investment. So instead of R, I put Y to calculate the yield to maturity. If I'm holding the instrument till maturity, I'm not reselling it in between. What is my yield? If I've paid so many payments, if I hold, this can be applied to a property also, right? You pay for a particular property that you buy, you pay EMIs, right? You pay to the builder also, you pay in installments, and to the bank also, if you're taking loans, you pay it in the installments. No one goes and gives away the money right away. Okay, take my money, right? You can calculate the yield on investment by using this formula. Whatever you pay, what is the price, and what are you getting in return, right? So why? By solving this equation, it will be a polynomial. If you solve this, you can ask your computers to solve this equation for you. Usually you have financial calculators. Bay Texas instrument is an instrument that is used to calculate all these N, T, R, Ys, all of these. So you're going to make 15.46% return, although the coupon is just 10%. But because you're getting payment every year also, right, by paying this, that means the yield to maturity, if it is held till maturity, if you don't resell it in between, this is the return on investment that you're making. Please don't worry. I'm going to share this slide with the host, right? They're going to reshare it with you if you want to refer it again. If you think it's too much maths for you, you can obviously re-refer it and see. And I'm sure it's nothing is rocket science. It's simple maths, fractions. We all use in our day-to-day lives, percentages, fractions. There are no technical formulas. Everything is very clear. As we see, all the information that we have is given, and we can simply plug it into the formula and get those values for us. We've spoken a lot about yield curves, I think. We now need to understand what this yield curve is. So yield curve is graphical representation of the relationship between yields of fixed income securities and their maturity, right? If an instrument, so for example, one instrument matures in 5 years, one in 10 years, what in 30 years. So how much do we expect the rate of return? What is the rate of return on it? What is the return on investment on it? That is nothing but the yield. They provide insights into the cost of borrowing. What is the investor? If I'm investing in a property or I'm investing in a financial derivative, right? If I'm investing for 10 years, then I should know what is the yield I'm looking at. I shouldn't have my expectation should be at par with the market, right? That is nothing but the yield curve. They provide insights into the cost of borrowing, investor expectations, overall state of the economy also. We will discuss further in the further slide why this yield curve is so important to understand whether we are in recession or whether the economy is in boom. These yield curves give a lot of insights. Again, this is bootstrapping the information from the curves that we see. Investors pay very strong attention to the yield curve since it has predictive powers. They tell you, whether market is, whether prices are going to rise in future, what are the levels of economic activity, right? Whether the economy is in recession or boom. If they want to basically make investment spending decisions, they can make based on understanding the shape of the yield curve only. Okay, moving on to the next slide. Yield curves. One is a normal yield curve, which is upward sloping, indicating if you make an investment for a longer term, you're going to make a higher yield, higher rate on return. And if you have short term, then you're going to make shorter, lower rate of return, right? This reflects expectation of economic growth and inflation, right? Okay, the economy is growing and the prices are going to rise in future. Whereas inverted yield curve, if it's in yield curve is downward sloping, right? Like this, it is negatively sloped. This is an upward sloping. Maturity increases, yield also increases. A simple sort of a straight line curve only. Obviously, these are not linear functions, so we have to show the curves like this. If maturity increases, the rate of return. If I invest something for 10 years, I'm going to get X amount. But if I'm going to invest something for 20 years, then obviously I'm going to get a higher yield because I've invested for a longer time, right? But an inverted yield curve, downward, short-term securities have higher yields than the long-term ones. That means, uh, it's a predictor of economic recession. If you see an yield curve like this, right? If the return on long-term investments is decreasing, that means we suffering nothing but the economy is going to be in recession very soon. If it's a flat curve, right? Then that means whether in maturity is 5 years or 10 years simply means the yield is same, right? It's a flat yield. Whatever you invest, we don't care. It indicates uncertainty or a transition phase in the economy, right? There is not much information about the economy that you can gather from a flat yield curve. And a humped yield curve, it is very common. It initially increases and then it gradually decreases. It falls for longer maturities. So it is less common. It reflects specific market conditions or imbalances in the economy if they're there. These are rare scenarios, but these are the most common scenarios, the inverted and the positive shaped. If the yield curve is like this, that means, okay, market is performing well, you can invest your money wherever you want to. But if it's a negative shaped yield curve, right, that is the time you need to reconsider your decisions and the make your investments wisely. You might be thinking, why do we have negative yield curves, right? Because if everything comes at a standstill, people don't feel safe while investing. It is everything about investor sentiment, right? What is the behavior of individuals? It is individuals like us which actually determine these shapes, right? If there are health concerns, if we have pandemics, endemics, problems like these, right? And it also depends on the uh, characteristics of demography. That means whether we have aging population, right? If the country has more number of elder people, they might not be that risk loving. They might not want to invest that much. We can have, for example, a classic example is Japan. In Japan, people will not be very, people are not very keen on investing a lot. We have negative interest rates also there. So demography, our investor sentiment, level of economic activity, all of those determine these yield curve, and these are in yield curve by shapes. Finally, we almost 1 hour into the session, we are talking about bootstrapping now. Bootstrapping of a curve refers to a method used in finance to derive a zero coupon yield curve, also known as the spot rate curve. We've already discussed the zero coupon rate. The return on a zero coupon bond, zero coupon yield curve is nothing but the spot rate which we are going to use for discounting. It is derived from the prices or yields of financial instruments such as bond and swaps. This is very clear from the example that I told. If you see on the right hand side, it's written swap rates, right? And on the left hand side, you have cash rates, you have forward rate agreements. So these rates are derived from such instruments. It is an iterative process You're going to see why it is iterative. That extracts the spot rates for various maturities by leveraging the earlier calculated rates. In simple layman's language, something that is there, you extract the information that you need, right? Multiple times, you might have to do some calculation multiple times. Please don't worry at all. I'm going to share the Excel. You can revisit it. You can ask questions. I will also give you my email ID if you wish to understand more on it, right? You can write to me. I'll respond. Uh, these are nothing but uh, this is nothing but the bootstrapping process. It's an iterative process extracting the spot rate of various maturities by leveraging the information that we already have. And why do we have information? Because these are from the most liquid, from the most frequently traded instruments, we get the information of what we need. Okay. First, we're going to talk about simple examples again. Then we're going to talk about the major examples in an Excel file. We will do that. Initially, we are going to bootstrap the information from normal examples. So, for example, you have 1 year bond. It is, I think, very apparent that we cannot get bootstrap a rate from one instrument only, right? We need to, as many data points we will have, we're going to make a better decision. We're going to come at better conclusion, right? More we research, better result we're going to get. As simple as that. So 1 year bond with a price of 980 and a face value of $1,000. And there is a 2 year bond with a price of 950, paying 50 annually. These are the these are the two bits of information that is available to me at the time where I want to bootstrap the rate. What am I bootstrapping? When I say bootstrapping, I want to calculate discount rate. Discount rate is nothing but the spot rate. Spot rate is nothing but the rate on a zero coupon bond. That is spot rate. Investment, if nothing is paid in between, I want nothing to be paid in between, right? From those, I want to calculate my discount rate. That's the basic idea of it. So for 1 year bond, that means time is 1 year. Price is 980. Paid in price is 980 means present value is 980. 980 comes here. Remember, we had discussed the formula PV is equals to FP upon 1 plus R to the power N. N is 1 here, right? So R, if I solve for R, this is nothing but the spot rate. The discount rate is nothing but 2.04%. This is the spot rate. Okay. Now from a 2nd year bond with the price of 950, paying 50 rupees annually. How do I calculate the price of it? Instrument is same. Face value is 1,000 only. It's a 2 year bond. So in first year, I will get $50 because it is paying $50 annually. It is for 2 years. That means in 1 year, I will get 50 and another year, I will get 1,050 rupees, 1,050 rupees or dollars. Right? In first year is 50. 2nd year is 1,050. Now you will say from one equation, you have two variables. How do you calculate this? I think your question should be this to me. But if you would have seen by solving the first equation, I already calculated the first spot rate, 1 year spot rate. This information I'm going to use in the second example, R1. I will substitute it with 2.04%. And now I have one equation and one variable. I can solve for R2 in this case, right? I think it's easy. You can solve it. Just solve for R2. It will be a polynomial with two degree polynomial. You can solve for it, right? That's how you're going to get the 2 year spot rate. To reiterate, with first information, I have price, I have face value, I calculated the spot rate, the discount factor of first year. But discount factor of first year might not be equal to a discount factor of 2nd year because time has increased, rate would have increased, instrument would have traded for a different price. Obviously, when if you increase the time, you cannot expect discount factor to be same, spot rate to be same. So what I will do, I will put this equation, take the interest rate, basically the spot rate from the first equation, plug it in the equation number 2 and solve for this to get the rate in this particular equation. Now bootstrapping of yield curve. This is the basic main thing that I wanted to share with you guys. I have already solved for this one, right? So here I have considered a curve rate, curve basically. I've considered JPY curve, which is nothing but the curve that is used in Japan. It's called ZT-Bor, as you see. It's every curve has a number, by the way, right? 490 is for US, 187 is for JPY, 42 is LIBOR rate. Like you have different curves. This information is very easily available. You can put the formula. I'm writing here ICVS, right? In Bloomberg. If you put if you give the command ICVS, it's going to give you the interest rate curves. And from therein, using this drop down, right now I don't have Bloomberg access. Uh, Using this drop down, you can choose the curve that you want, right? Second thing, which is very important before we start going into the Excel, I'm going to speak 2-3 minutes about the settings that you might want to do, is change the date, right? This calculation is as of 4th, 1st April, 4th month of 2023, right? So valuation date is very important because as you know, as dynamic as you see in your kites or your Zerodha scheme is basically of those apps, the prices of the instruments change very quickly. Similarly, rates also change very every day. That means it is very important to set a fixed date for it, on which date that you are valuing or calculating all of this, where the date on which you are making the analysis, that is nothing but your valuation date. Got it? So valuation date is very, very important. As I said, 1st April 2023 is the valuation date on which I'm making all of this decision. So bootstrapping is done as of 1st April 2023. This is nothing but my valuation date. Now you see something written as actual by 365. This is nothing but the discounting day count convention. It's called DC convention. That is this day count convention. That means for simplicity, right? We have leap years, we have normal years also, right? We have number of days usually in a market are, in a year are 365 days, right? But we have a lot of market conventions for different instruments, which you will see at the end of this page. So short end, that is for very short end, the number of days, the day count convention is called actual by 360. This is the day count convention used for short rates. For medium run, it is used actual by 365. For swap rates, it's actual by 365. And then there is semi-annual compounding also. That means this swap is exchanged every 6 months. Okay. You have to see the day count convention. What is actual by 360? I'm going to come to it. What is actual by 360? Actual is, I'm sure 360 and 365 is the normal estimation of the number of days in a year. It's very clear to all of us. But what is the concept of actual that I'm going to talk about now very soon? So here the start date and the end date is already given to us. These are the par rates. In bootstrapping, what am I doing? From par rates, I am going to get my spot rates. That's the intention. I'm going to use this to get spot rates. Simple. I'm bootstrapping from the information that's there available in the market. Why par is available? Because it is traded at par, fair value. I'm going to get spot rates, which is used for discounting, right? We have par rates and we want the discounting rates. Okay. Now, if you see over here, this is the Excel. We have to talk about day count convention first. That I'm going to tell. So for example, the information that I have today is 6 months rate is available, right? 6 months from April, 1st is 1st April, 6 months from 1st April is 1st October, right? So what is the day count convention that I have? It is nothing but actual by 360. I need to calculate the actual number of days between the date that I'm considering, right? You will see everywhere it is 1st April except for this particular line. And why? Because this is a forward rate agreement. This is a forward rate agreement. In forward rate agreement, what we have is this is starting after 6 months. So I have to put the date of 6 months, and this ends for now. This lasts for another 12 months from now. 12 months from now. So because my valuation date is 1st April 2023, that means the end date is nothing but 1st April 2024. It starts today. It starts 6 months from today. That is 1st of October 2023, and it lasts for 12 months from today. That means 1st April 2024. For rest of the dates, by using these maturity of the instrument that is available, I am calculating the end date. This is the start date. Start date is nothing but the valuation date that I have today, except for the FRA that I've already explained to you. Tenor is nothing but the difference in both these time periods, that is tenor, right? We know that this forward rate agreement is also traded for 6 months only, but because it lasts for a year from now, that is why it is important to consider this also. Although the number of days are same in this case, but it gives me information, insights about 1 year from now. That's why it is important that I consider forward rate agreement that starts from 6 months from now and ends after 6 months, 12 months from now, right? These are my tenor. Tenor is nothing but my difference between these two. Now, after calculating this, right, it is not, my discount factors basically are not very easy to calculate. For first year, for half year and first year, I can calculate very easily using this information. Discount factor is nothing but 1 upon 1 plus R, right? But R is annual rate. Is 183 an annual day? Does it comprise of 1 year at all? No, it is less than 1 year. What are the number of days between these two dates? It is 183. So I need to consider the proportionate rate only for 183 days. That is why I need day count convention. Why do I need day count convention? Because the rate that I'm getting is for 1 year, right? I want to, in the formula, right, I want to annualize that rate. To annualize that rate, I will multiply it with by j by 36, because for short term instrument the day count convention is actual by 360. That is why I am going to multiply it by actual. What is the actual number of days between these two dates? 183. J7 is nothing but 183. So 1 plus 1 plus r is nothing but the par rate that I have, and I'm going to get the discount rate for this particular instrument like this. For these two, we can calculate similarly for this one. We will get by doing this. And since it starts after 6 months, I also need to multiply the discount rate of the previous year. I know it can be overwhelming for the first time, but if you revisit, it's going to make sense to you. And this recording is also available with the host. You can probably take that. And if you're not taking notes, you can revisit my recordings and understand. For the first year, I'm annualizing the rate. That is why I'm considering actual by 360. For the second year, because this instrument starts 6 months from now, I also need to account for this period, April to October. That is why I have to multiply it with the previous discount factor, which is nothing but I've already calculated K7. So after getting these two values, right, from now on, it is not very easy to get the discount factors, because the instruments that we have now, they are not simple instruments. There are swap which are traded semi-annually, right? So I've done a working for this here in the sheet. If you see, after every 6 months, semi-annual, because it says S by A, S/A, that means nothing but semi-annual, right? So for semi-annual, we have every 6 months something is exchanged, right? And it starts from 18 months. So basically from here, 18 months is nothing but 1.5. This particular row, I want to highlight this one. Yeah, this one. It starts from here, the rate that you see, right? I'm going to calculate it for you. And to build on this, as in this example, the example that we did, for second year, we already used the information of the first year available. Then only we were able to calculate the information for the second year, right? We had to use the first year information to get the second year information. That is why, for the same reasons, we have to use the discount factors, right? of these years and the rates of these years to get the information of further basically swap rates, right? Now, what we're going to do is we're going to first calculate the swap rates are available. Whatever swap rates are available, we will see. See, swap rates are also 10, then after 10 years, they are available for 12, 15, 20, but we need at every 6 months. So what we will do, we will interpolate for the rest. If we know the rates in between, we'll do nothing but interpolation. I have talked about interpolation in my slide too. Let me show it to you what interpolation means. I know we are running short of time, but I hope we'll be able to cover it. I'm trying my best to do that. Yeah. Interpolation is a mathematical method which uses linear polynomials to create new data points between two data points. So for example, if in this curve, I know this point and I know this point, anything between this can be interpolated using a mathematical formula. The right, you can basically linearly interpolate. If I know 1 point and 2 point, I can calculate a point between, because most likely it's going to fall between those 2 points only. That is the process of interpolation. I'm sure we've used it in our other day-to-day lives also. This is the formula for linear interpolation. I have already embedded it in the Excel. When you get the file, you can refer to it. Here I'm using it as a function to linearly interpolate my rates. Right. Now, how do I calculate my discount factor? I already have this discount factor and this discount factor. First, I will interpolate all the rates that I have. Then I will calculate the discount factor, right? Once my rates have been interpolated, I can calculate the discount factor with the last formula that I'm going to tell you in this class, right? Second last, okay, fine. So for interpolation, very important to understand, right? Using the 1.5 year swap rate. So for example, first rate is known to us, right? 0.5 year ke liye we have already calculated using the cash rate. Using the cash rate, I know the discount factor, what is there, right? Now, using this one, using the second information of the forward rate agreement, I can also calculate the discount factor of the first year here. So the information that I have with me right now is information of 0.5. Then I have the information of 1 year discount factor also. I need to get the information of discount factor of 1.5 year. How am I going to do? I have the swap rate that I've already interpolated in the Excel file for 1.5 year. I have the swap rate for 1.5 year. It is available to me. If you want to see 1.5 year ka swap rate, it's nothing but the average of these two values, right? It's going to fall somewhere between 0.11 and 0.169, which is somewhere around going to be 1.41. This is 0.114 basically is going to be the interpolated value that we have calculated. All the swap rates we have calculated, and discount factor is something that I'm calculating right now. Swap rate I have interpolated with the information that I have, and discount factor is something that I'm calculating now. Remember, I'm repeating again, in this file that I'm going to use right now, I am telling you with the existing information that we have. We have the swap rates for 1.5 year from the market, right? We know what the swap for 1.5 year is being traded for. Discount factor for 0.5 year and the first year, we have already bootstrapped from the instruments that were available, the cash rate and the forward rate. Now I'm going to get the discount rate of 1.5 year. I will put the values of 0.5, 0.1, and using this resolving this formula, then I'm going to put the values. I'm going to take it here, then solve it for discount factor of 1.5. DF of 1.5 year will be calculated. Now, if I have the discount factor for 1.5 year, if I have a 2-year swap rate available with me, then using that 2.5 2-year swap rate, I will put the value. R2 means R for 2 years. R1.5 means swap rate of 1.5 year swaps, right? How many payments will be there in 1.5 year? If there is one payment semi-annual, remember the payment convention was semi-annual. There will be 3 payments. After 6 months, then after 1 year, and then after 1.5 year. If it's a R1.5, basically if it's a 1.5 year swap. If it's a 2-year swap rate, then we expect 4 payments, because after every 6 months, if the payment convention is semi-annual, the frequency is semi-annual, that means I'm going to have one discount factor for six months, then for 1 year, then for 1.5, and then for 2 years. What is known to me? R2 is known to me. From this information, if you see, R2 is available for me. 2 year ka value is available for me. What I will do? I will put the 2 year value. I know discount factor of 0.5 also. I know discount factor of 1 also. I know discount factor of 1.5. I just calculated. Then using the available information that I have. That is why when we said we have to do it iteratively for every year. Remember, please go to the slide to understand why I use the word iterative in bootstrapping. It is an iterative. Iterative means after every step, you put the information you derived from the step one before, you put it in the next step and get the extra value for that second year, basically. You extract that rate by already earlier calculated rates, right? So we're going to get for, if we have the information available for basically three terms before 0.5, 1 and 1.5, we can calculate for 2. Similarly, in the Excel that you would see here, I have calculated after, this is an iterative process of getting the discount factor. After this is calculated, then this is calculated, then this is calculated using all the information above. This is calculated using all the previous information above. Similarly, if I talk about this is calculated using all the previous information from above, right? And every time you will see me multiplying year frac is a function that I have used. Sorry, year frac is a function. I have not given any questions about this. Please, I've given you very simple questions. I can understand that this can be overwhelming, but this is a very, very upcoming skill in the market. If you know bootstrapping, it's such an important concept in finance and market risk. And I'm sure you can leverage it in other fields also. It's simple. In layman's language, if you have some information, using that information, you can gather insights, more insights, can delve deeper into some topic. That is nothing but discount rate bootstrapping, right? So you have derived discount factors for every every 6 months, and using these discount factors, you will basically put a VLOOKUP formula, get for those particular years the discount factor, and from this discount factors, you can calculate the spot rate, which is nothing but the zero rate. How are you going to calculate those rates? These rates are calculated using this formula. We know that, amount and annual payment is nothing but the principal into ERT. This is the time value concept. Or discount factor is nothing but 1 plus R, right? That we have discussed to the power T. Yes, sorry, I forgot to put T. Please excuse me for that. So that means E minus RT, right? This should have, sorry, control C. Yeah. Discount factor is minus RT. That means R, the zero rate, the spot rate is going to be minus ln of discount factor upon T. That is the formula that I have used here. Minus ln of T is nothing but whenever we want to calculate T, time period, that is year fraction. It's going to give you the number of years between those two particular days, right? You put the start date, you put the end date. Three is the formula where you get the day count convention. For example, if I'm putting year fraction, right? Year frac. If I put the start date as this, then I put the end date as this. The day count convention that we just spoke about, actual by actual, if I want to consider leap year, that means 366 days. So actual by actual, it can be actual by 360, it can be actual by 365, depending upon what the information says. I have used 3 here for this one because it is actual by 365. So I'm going to put 3 here. That means day count convention is also considered in this simple formula, 4 years, right? Because we want to be as accurate as possible, that's why I've used these formulas. Please don't get overwhelmed these formulas. It's give 4. If you see the dates, you will think it is 4, but it is slightly more than 4.04 years. That also is accounted using the formula year fraction, right? That you can consider. I'm going to share this Excel. Please write to me if you have any questions. I want to wind it up, so I'm not spending a lot of time here. I also want to talk about the applications of bootstrapping. It is used to price derivatives, bonds, fixed income, securities on the spot rates. It is used in risk management, basically to understand, it aids our understanding in forward rates. It helps in hedging strategies. It helps in interest rate modeling. There are multiple market risk models you can read about, Black-Scholes, Hull-White. There is John C. Hull. It's a, Bible for people who are in finance or market risk. Uh, that is very important. So maybe you can read these models, Black-Scholes, Hull-White, Merton model, Black 76, all these models, and these inputs are used in interest rate modeling. If you are considering changing of field from where you are, if you are supposedly in finance, and if you want to come to corporate, these tools will come very handy, basically to aid your understanding. And last, uh, this is what we have spoken about. It is in valuation, risk management, and interest rate modeling. Valuation is something that we also do. Valuation of of anything that holds value, right? It could be of a physical asset, or it could be of a financial asset. Bootstrapping is. I have given you examples of real estate. I have given you examples of interest rate instruments also. Valuation of anything you can do using that by applying the application of bootstrapping. For fixed rate, basically for financial derivative, I've taken example, I've shown you bootstrapping. Similarly, you can read about bootstrapping of other instruments also. uh, I can share this slide and let me know if you have more questions on this. I will stop sharing my screen and share this slide with the host. Please let me know if you have more questions on this.
Dear participants, if you have any question, you can post it in the chat box.
I see somebody said the first year value should be 1050. Could you please write it further? Which slide are we talking about? Murugappan, could you please write where you're talking about the first year rate value? See, nothing is fixed. I'm not sure if you're here listening to me right now. It depends upon what is the discount rate. It depends upon for how many years you are considering it, right? Based on those points, you're going to discount. Second year, we've taken it. Okay, you're hearing me. Second year, maybe you can write it to me and we can carry forward it after discount, because I'm not able to understand which slide you're talking about right now. If you have any general specific questions, then I can take up right now. If you have specific question about the slide, I can take up after the session also. Uh, I'll just share my screen again to give you my contact. Please write it to me on this one with the PPT. Once the host shares the PPT, you can write it to me. This is my personal email. This is my official email ID. You can write on either of them and I'll respond to you. I'll respond from my personal only. So maybe you can respond to me on my personal email. I'll prefer this. But if you have CVs to refer, if you're considering a job change, then you can refer, you can send your resumes to me on my professional ID as well.
Thank you so much, Aastha, for the insightful session on bootstrapping of interest rates. It
Okay.
was an enlightening experience for all of us as we delved into the intricacies of bootstrapping and its significance in the financial industry.
Okay.
You have explained the concepts in very simpler way and made it easier for the non-finance domain participants as well. So I'm sure that after attending the session, the participants will now have much stronger foundation to build upon. Thank you once again for the inspiring session.
Okay, you're welcome. I think I just got a reply from him. You're saying slide number 14 and 15. Okay, so these are just examples. When I'm saying price is this and face value. For the first year, when I had given an example, I said 1 year bond with a price of 980 and face value of 1000. Right? There is no there's no fixed price. This is just an example to bootstrap, to explain you bootstrapping. It's a zero coupon. Uh, when I'm paying 980 in the beginning of a year and I'm getting 1000 at the end of the year. Right. Second, I'm not saying 1050 for all. That was another example. I think you're confusing between two examples, Murugappan. Maybe you can see the slide and understand. Yeah, I think you understood it. Great. Hmm. Okay, I hope it's clear. Gaurav, I'll share the slide and the Excel that I've used for the explanation with
Okay.
you. Yeah. I'm guessing no more questions. I'll wait for another 2 minutes.
Actually, yeah, because the assessment window is going to open at 6:30, so we have to brief them about the process of appearing
Okay,
for the
okay.
assessment.
Then I'll pause. Okay, sure. Hmm.
Thank you so much, Asta. Thank you so much. Okay, dear participants, we have shared the feedback of all the three sessions and the attendance form on your WhatsApp as well as on your email IDs. Do fill that as soon as possible. We are about to start with the assessment session shortly. Before that, let me have a presentation. Yeah, I hope the screen is visible. Mamtam, shall we start or shall we wait?
I think we can start because assessment will begin at 6:30 on portal. So we can give
Okay.
instructions right now.
Okay. So how to give test? So first of all, you have to log into your AICTE ATAL portal using your registered email ID and password. And then this web page will show up. You can put your email ID here, put the password, and put the captcha, and then sign into your account, ATAL account. After logging in, you will go to assessment that will be showing it here. After clicking here, the three lines, you will the assessment option will be shown here. Click on the assessment option. Then there will be a link. Okay. That link will get activated at 6:30 sharp. So you will have 1 hour window to appear for the test. This test will be only visible to those who have more than 80% attendance. So once you click the link, then this window will show up. You just click this I have read, understood and will adhere to the assessment guidelines. Click this option and then you can start with the test. Okay. After once the test starts, appear for it. Then after the test, you can also you have to fill the feedback form also on the same portal. It is mandatory for each and every participant. Okay. And then you are done. Okay. So both things are important, assessment test as well as the feedback. Okay. Okay. So I think we have 5 minutes. Yes, it will be all MCQ questions. If you have any doubt, you can write down in the chat box. 6:30 to 7:30. It's okay. Whatever email ID you have mentioned in the attendance form, it's okay. But make sure that you register, you enter your login ID in the ATAL webpage. No, no, don't log out this session. Please be there in the session only. We will be sharing all the instructions. Be there in the session. So we have 5 minutes. Meanwhile, if anybody of you would be interested in sharing the feedback of this ATAL FDP, please raise your hand and switch on your video. You can share your experience in 1 or 2 minutes quickly. Please, you can raise your hand. We will unmute you and you can turn on your video. Vivek Birlaji. Yeah. Please start your video, Vivek ji, and I'm giving you right to unmute. Yeah. Yeah, you
Hello.
can share.
Yeah, good noon to everyone. Good evening to one and all. First of all, a big thanks to Mamta ma'am and the entire coordination team. I'm Vivek Birla. I'm right now attending this session FDP from Moradabad. I'm working as a senior assistant professor in the management department. And ma'am, this entire workshop is more on the data analytics, more on the tools. Today's session on the bootstrapping, the first session by the Anjali ma'am, the all these sessions were very practical, whether they are taken on the current technologies, future technologies, or even they are somewhere related to the market related upskilling programs, tools. The best part is that you and your team, everyone is very proactive, keeps on sharing the data and maintain the integrity of the workshop, the FDP. You had usually in the FDPs, we see that this workshop attendance is updated or the FDP attendance has been updated later onward, but your proactive things had been seen. All the attendance are equally marked out. The assessment is also on the A.T.A.L portal, which is a positive side. And the speakers selected for the session are much more as beyond the expectations. They are from the industry. Today's session by the ma'am, her skill or her learning from the KPMG has been reflected, directly reflected into the session. And the session on the Python, personally, if I see, I have enjoyed all the sessions, and hopefully, I will carry these sessions into my classrooms and into my real world assessments also. Thanks a lot, Gauravji. Also, you had been a good moderator and also a good person who had been into the session throughout the time. Thank you.
Thank you, sir. Thank you so much for sharing the feedback. Dr. Inu, please, could you start your video?
Good evening to everyone. First of all, thanks to the organizer team for arranging such beautiful sessions. Thank you. Thank you so much.
Thank you, ma'am. Anybody else would like to share their experience? Please raise your hand. We have taken so much effort in organizing this FDP. So we want that, most of the people will get benefit out of it. So we have Dr. Pallavi with us. Yeah, you can start with your video. You can unmute Dr. Pallavi. Please unmute yourself. There is some technical issue.
Hello. Hello.
Yes, sir.
Sir, just one small query. Our FDP, which has been listed on the assessment side and even on the AICT Adult portal as of now, the name there is a small mismatch as compared to what it is on the brochure. I assume there is some either typing error or there may be because it may impact the certificate part also in case if it is not updated on the portal. The mail which was being shared from your side, it says essential data analytics skills in the application in the business management. But when I'm checking it out on the portal, it is advanced computing, supercomputing, AI, quantum computing. This is the
These are the
thing which
sub areas. Sub areas. These are not the title of the FDP, sir.
so
This
if we
is not
go
the
on the
title.
assessment side, sir,
These.
if we are going on the assessment side
Mm-hmm.
or even on the feedback, on the feedback, it is showing it is showing the application number. But if I'm going there on the feedback, yeah, on the feedback, again, it is just showing the thrust area. If I am saying, if you are saying, there is no name of the um,
I,
FDP as of now.
Sir, it will get reflected on the certificate as well. Don't worry.
Okay, so this was just small observation. If it is there is nothing to worry, then it's okay, sir.
application
Pallavi,
ID would be there for FTP, but name would not be there for now. And this is the thrust area which is showing in feedback and assessment. And one more thing I would like to share that we have also shared a Google form through mail. Just in case there is some problem with the portal or the network of the participants, so you can fill through the Google form as well. So if in case there is no updation from the portal, we can manually do it through the marks which we have obtained from Google form. So kindly check your mails also for assessment. We have shared a Google form as well. So fill both Google form and on portal as well. 25 questions are there and all are MCQs.
Ma'am, both
Doctor,
are required to be filled, or either of the
In
one.
case you are done on portal, then you need not fill the Google form.
Okay.
over to you, Dr. Pallavi. Please share your experience.
Good evening, everyone. I, Dr. Pallavi, working as assistant professor, and I would like to extend my heartfelt thanks to the entire organizing team for organizing such a wonderful FDP. And all the sessions were such informative and enlightening for us, and we learned many new things. And I wish the institute would continue doing such programs in the future as well. Thank you so much.
Thank you, ma'am. Thank you so much. Now, we can all attempt the test on the A.T.A.L portal. Mamta, could you share the PPT once again? Yeah, just play the slideshow. You have to score more than 80%, 70% in the uh, quiz. There is no such negative marking. You all can log into A.T.A.L portal, then click on the assessment. Click on this link, assessment link, and then you can start with your test. All the best. Be here in the meeting. We'll be sharing important instructions. We have valedictory session with the after this assessment session. So it is also mandatory to attend that session. So be here in the meeting. Okay, just after this assessment session, we'll have valedictory session as well. The session will start at 7:30 till the time you must be there in this meeting. Okay. So all the best, everyone. Start attempting your assessment test. There is one query that can we use the assessment link for the exam that you shared in the email, or should we only use the website? See, it is mandatory to attempt both the links. First preference would be the A.T.A.L portal, because it is mandatory there to appear for the test through A.T.A.L portal. In case if you are having any issue while attempting the test on A.T.A.L portal, you can appear for a link which we have provided in the email. Okay, so to be on safer side, first log into AICT A.T.A.L portal as soon as possible. Check your internet connection and try to appear for the assessment on A.T.A.L portal only. Okay, because this link is only open for 1 hour till 7:30. After that, you will not be able to appear for the test on AICT A.T.A.L portal. If the portal is not working, if you're having any technical issues with the portal, kindly fill the Google form for the backup. You have received that link on your email ID. Do fill that form and keep trying to, log into AICT portal. Keep trying for the AICT portal as well. Yeah, if you're facing a issue related to submitting the feedback on the AICD portal, so what you can do is you can refresh that tab, but don't refresh the tab when you're attempting the test. Okay. Yeah, just refresh the feedback tab because there are many FDPs that are being happening right now, and many participants are giving tests. That is why the uh, portal is having some technical issue. So I would suggest you to fill the Google form as a backup. Mamta ma'am, shall we start with valedictory session now?
Yes, sir, I think we should start.
Okay. So good evening, respected guests and participants. On behalf of Maharaja Surajmal Institute, I welcome you all to the valedictory session of 6 days online at FTP. As we conclude the faculty development program on essential data analytics skills and applications in business management, I'm filled with gratitude for the knowledgeable and insights shared over the past 6 days. I'm elated to announce that we had 211 participants from Delhi, Rajkot, Pune, Mumbai, Uttarakhand, Andhra Pradesh, Tamil Nadu, Hyderabad, Rajasthan, Varanasi, Coimbatore, and many more places. The experts in FDP were invited from academia and industry to share their valuable knowledge in different domain of data analytics. For the past 6 days, there were 13 sessions in which we explored key concepts, tools, and techniques in data analytics, gaining skills that we will transform our teaching, research, and academic practices. Now I request Dr. Mamta Gupta, coordinator of AICTE ATL 6 Days Online FTP, to present vote of thanks.
A graceful and warm evening to one and all present. Prior to winding up the event, a few words of warmth to all who have helped us in making this event a very resounding success. We are fortunate to be a part of Maharaja Surajmal Institute, which is an organ of Surajmal Memorial Education Society, which has always been a source of motivation and determination. I would like to give my hearty vote of thanks to Honorable Chairman Sir Shri Kaptan Singh Ji and all the respected members of the Surajmal Memorial Education Society, all HODs, faculty members, and the staff of Maharaja Surajmal Institute. Special thanks to Professor Hari Singh Sir, Director MSI, for his constant support and motivation. Thanks to all the faculty members of the Department of Management, MSI, and co-coordinator Dr. Sarita Chaudhary for providing the support in organizing the event. On behalf of Maharaja Surajmal Institute, a heartfelt thanks to our speakers for sharing the valuable insights and delivering interactive and generous sessions. It was a pleasure to have you all on board and connect with you on this learning platform. This program not only provided foundation, but also hands-on training sessions for better learning. Special thanks to the participants for their unwavering support and for being attentive during the sessions. I would like to thank AICT Training and Learning, ATL, for giving us the opportunity to conduct an online FTP, which provided a learning platform for participants from Pan India. I'm confident that lessons learned will guide us in shaping the future of education. Thank you and best wishes for your continued success. Thank you all.
Thank you all participants for being there. I can read many messages have come up in the chat box that they are having some issues with their portal. So do fill the assessment through Google form as well if you're facing some technical issues. If you're facing any technical issue while filling the feedback form on AICD portal, then you can refresh that tab. And again, you can, fill the feedback form on the portal. Filling the feedback form is very important on the AICD portal. Otherwise, it is a mandatory thing. Otherwise, the certificate will not get generated. Thank you once again. Shall we end the meeting, ma'am? Or shall
Yes,
we
sir.
wait?
Actually, if you have queries regarding no certificate issued, actually there has been so much of traffic on this AICT portal, so there might certificate will be issued once you have submitted the feedback. So wait for few more time.
Minutes.
Uh,
Due to because many FDPs are taking place, and they
Parallelly,
all
there have
are.
been many FTPs running, and same time have been provided for feedback and assessment on the portal. But make sure that you fill the feedback on portal also, because that will generate the certificate for FTP. One of the query is that they are not able to enter the resource person name and feedback. Reason would be the same because there have been too much of traffic on the site. So it is not showing the options. You can refresh it or log in again. Ankita, if it is showing already submitted, then what you can do is you can try login again after a few minutes and then check if it is already submitted or not. Can we end up the meeting, sir, now? I think no more queries are there. Login में problem है ये Google form में submit कर दिया है. Yes, if you have submitted in Google form, that would be okay. But make sure that you have submitted feedback on the portal.
One query is there. Till what time we can fill? When a participant is asking.
I think feedback would be open. नहीं हो रहा. Yes, portal is creating a problem right now. So if in case you are not able to log in, fill the assessment in Google form. And after some time, you can try to fill the feedback on portal. But make sure you fill the feedback on portal. I'm repeatedly telling you this.
Okay. So thank you so much, everyone. And okay. So as Mamta ma'am said, that it is important to attempt the quiz, attempt the there will be 25 questions, so it is mandatory. And if you are having any issue on AICT portal, it is recommended to fill on the Google form. Okay. And after that, you have to fill the feedback form, which is there on the AICT portal. That is also mandatory. After filling the feedback form, you will get the certificate. Okay. Thank you so much for being